Good evening, everyone. Good evening, everyone. We will begin shortly. Kindly check your audio and connectivity. Please stay muted until the formal program begins. We'll resume shortly. Kindly stay connected.
हाँ घर है गोल्ड है तो सुनता है
Before we begin, I request all the participants to kindly turn off your camera and keep your microphone muted. to ensure a smooth and disturbance-free session. Please unmute only if you are asked to interact. Thank you.
Hello. Good evening, ma'am. Madam Kanyakumari.
Father,
Hello.
good evening, Father.
Good evening. I am inside.
Yes, Father. We will start, Father.
You want me to open the video? No need of video.
Niharika, ma'am.
Ma'am, shall we start?
Yes, ma'am.
Okay, ma'am. Good evening, everyone. I warmly welcome you all to day one of online ATAL Faculty Development Program, organized by the Department of Computer Science
Ma'am,
and
your
Engineering.
voice.
Is it audible, ma'am?
It's audible to me.
Okay, Father.
For others, they have to check probably their instruments.
Okay.
Audible, madam.
Okay. Thank you, sir.
Yeah, audible, ma'am.
Audible, madam. It's clearly
Audible,
audible,
ma'am.
ma'am.
It's my privilege to welcome our dignitaries, Reverend Dr. Emmanuel Father, Assistant Director of Andhra Loyola Institute of Engineering and Technology, Dr. L. Kanyakumari ma'am, Head of the Department and Faculty Development Program Coordinator, Dr. K. Sirisha ma'am, Co-Coordinator of Faculty Development Program, and all faculty participants joining us from various institutions. We welcome you all. Andhra Laila Institute of Engineering and Technology is a prestigious Jesuit institution known for academic excellence, ethics, and service. The college is accredited with NAC A+, reflecting our high standards in quality education and institutional performance. In addition, several departments hold NBA accreditation, demonstrating our commitment to continuous improvement and outcome-based education. Aliet offers strong engineering programs, fosters multidisciplinary research, has achieved patents and funded projects, and maintains active industry collaborations through MOUs. The institution proudly hosts student clubs, innovation driven activities, extension programs, and national level technical events. We regularly organize FDPs, workshops, training programs to enrich faculty and student learning. This faculty development program is conducted under the AICTE ATAL Academy, which works to enhance the professional development of educators across India. Vision of ATAL to empower faculty to achieve goals of higher education, such as access, equity, as well as quality. And the mission of ATAL is to provide world-class training, hands-on exposure, capacity building opportunities through structured FDPs and expert-led sessions. This FDP is themed Intelligent Systems and Generative AI, advancements in deep learning, robotics, and applications, scheduled from December 1st to 6th of December. Program aims to strengthen foundational concepts, research skills, and practical exposure in AI, deep learning, intelligent systems, and their real-world applications. Now, I request our respected Assistant Director, Reverend Father Dr. Emmanuel S.J. to address the gathering. Please, Father.
Respected Head of the Department of Computer Science and Engineering, Dr. Kanyakumari Garu, and other associate professors, assistant lecturers, and other participants who are as logged in to participate in this program. I would like to extend my warm welcome to each and every one of you. Andhra Loyola Institute of Engineering and Technology offers a hearty welcome to each and every one of you. As we all know, this particular training program, which is from 1st of December, that is today, up to 6th, is really a very useful program. Quite recently, all of us attended also FDP at the college level on generative AI, how to use generative AI and then prepare education-related tools. In fact, today I was reading newspaper. The newspaper, one of the doctors in Vizag, he claims that he has conducted 100 surgeries, cancer surgeries, onco surgeries using robotics. See, the robotics are being applied in different walks of life. Similarly, these intelligent systems and generative AI will find its application almost every field in our life. Whether it is a manufacturing industry, now they are saying computer-enabled manufacturing. And being an engineering college, almost every engineering subject also has to fall in line to use this generative AI and then improve their own fields. Like every branch is now computerized. Therefore, very important type of training. Another thing is, we are living in a time where knowledge boom is there. So information boom. Every click of a mouse, the knowledge system keeps on increasing. So we have to keep in touch with that. As we are all educators, we are molding students. All the lecturers are doing a noble job of working with human beings. Others may work with computers and machines. Lecturers, is a noble profession, teacher's job. So we need to do justice to these people. Therefore, we have to do a little bit of hard work at this point of time to improve our knowledge. So it's an ongoing learning process, and we need to be learning new systems, new knowledge, so that we will not be left out. The world is going very fast. It is something like the train moves very fast, and then if you are not able to catch up to the speed of the train, we will be left out. So it's very, very important for us to learn. So all these 1st of December to 6th, kindly spend your time and then learn from all these sessions. That will really build up your capacities. With these few words, once again, I offer my wishes, best wishes, as well as my prayers so that this particular program goes on well. Wish you all the best. Thank you.
Thank you, Father, for your insights on Gen AI. I now invite Head of CSE Department, Andhra Loyola Institute of Engineering and Technology, FDP Coordinator, Dr. L. Kanyakumari Ma'am, for her remarks. Ma'am. Kanyakumari Ma'am.
Yes, ma'am.
Yes, ma'am.
Good evening, everyone. I extend a warm welcome to our beloved Director, Reverend Father Dr. B. George Reddy, SJ, Reverend Father Dr. S. Emmanuel, Director of Examinations, our esteemed Principal, Dr. O. Mahesh, the heads of various departments, faculty members, and all my dear participants. A very good evening to one and all. It gives me immense pleasure to welcome you to the AICTE ATAL FDP on Intelligent Systems and Generative AI, Advancements in Deep Learning, Robotics and Applications, organized by Department of Computer Science and Engineering, Andhra Loyola Institute of Engineering and Technology. I'm delighted to share that our proposal has been accepted by AICTE. This FDP stands as a testament to our department's commitment to academic excellence, research growth, and continuous faculty upskilling across the country. I express my sincere gratitude to AICTE and the ATAL Academy for providing us with this opportunity and for their constant encouragement towards innovation-led teaching and learning. As the coordinator and head of the department, so I encourage all participants to make the most of this program, engage actively with the resource persons, ask questions, collaborate with fellow participants, and reflect on how these learnings can be incorporated into your teaching, research, and institutional activities. The true value of this FDP lies not only in listening, but in effectively applying the knowledge gained. So this artificial intelligence encompassing data science, deep learning, and generative AI is no longer limited to laboratories or research publications. It is reshaping industries, transforming automation, redefining creativity, and enhancing decision making. This FDP aims to offer a deeper understanding of these advancements, bridging the gap between theory and real world practice. I also wish to express my sincere appreciation and thanks to our management, the ATAL team, the organizing committee, technical staff, and faculty colleagues for their support in making this program possible. My heartfelt thanks to entire organizing team for their dedicated efforts and to all the participants for their enthusiasm and active involvement. Wishing everyone a fruitful, enriching, and inspiring 6 days of learning. Thank you.
Thank you, ma'am, for your insights. A quick note to all the participants regarding this 6 days FDP program. please maintain attendance for all the sessions, minimum of 80%. Submit feedback forms as instructed. Certificates will be issued as per ATAL norms, which are including final day assessment of minimum 75% and attendance of 80% in your participant login only. Keep your mic muted and use the chat box only for queries. For any technical issues, our support team is always available. Moving further, now it's my pleasure to introduce our distinguished resource person for today's session, Dr. M. Srinivas, Assistant Professor, Department of Computer Science and Engineering, NIT Warangal. He holds a PhD from IIT Hyderabad, who has completed international postdoctoral research in Canada and Taiwan, and has over 75 invited talks to his credit. His research spans image processing, medical imaging, computer vision, sparse representation, and deep learning. Dr. Srinivas has an impressive 52 publications, which include 12 journal papers, 35 conference papers, 3 book chapters, and 2 textbooks. He has also received multiple prestigious national and international awards, authored a Whaley publication, and delivered more than 75 invited talks. With vast academic research and professional experience, Dr. Srinivas is a highly respected expert in the field. We are honored to have him with us today. So before handing over the session, so do kindly have a note to maintain the attendance for all the sessions, as well as to submit the feedback forms and to have the assessment, final day assessment of minimum 75% and attendance of 80%. If you have any kind of queries or anything, please use the chat box. So before we warmly welcome our resource person, I request everyone to stay muted as well as kindly bear with us for a moment.
Hello.
Before we start our technical session 1, we'll have a quick glimpse of Andhra Loyola Institute of Engineering and Technology. We warmly welcome Dr. M. Srinivas, sir, Assistant Professor, Department of Computer Science and Engineering, NIT Warangal. Sir,
Yeah, good evening.
good evening, sir.
Yeah.
So we are handing the session to you, sir.
Yeah, thank you.
Okay.
Yeah, my screen is visible.
Yes, sir.
Yes, sir.
Yeah, good evening to all the participants. So in this session, I want to give the deep learning related concept and how we can use for the medical images classification problem. So if you have any doubts, any queries is there, you can unmute and you can ask. Okay. So first of all, before start the deep learning, so what are the stages is available in machine learning? Everyone knows. Okay. So one of the important stages the in the machine learning is the feature representations. So depending on the data, maybe data is available different formats. So maybe image that is the data may be text related, or maybe it is a tabular form, or maybe it is the images related, or maybe video related. So depending on the data type, we need to extract the properties or features. So the properties or features will give the unique information of the or unique identity of the your data. So like that we can extract the properties. So the properties extraction is nothing but the feature representation. The important stage in the machine learning is the feature representations are important. So based on that only we can easily discriminate the objects. So simple one example I will give. For example, I have the one red color apple is there and one yellow color banana is there. So my question is, how can you discriminate these two fruits? Any answer? So this
By
is
using
the
colors.
color. So here I use the based on the color. Can I discriminate? Any other?
Shape. Size of the fruit, sir.
Shape.
Shape,
Size
sir.
of the fruit.
Size of the fruit. Okay. Size in terms of what? For example, you can measure it in terms of weight. Maybe two fruits have the same weight kind of is there. So for example, I use the another kind of thing, taste. So here my first question is, based on the color, can I discriminate? I said it is the apple is the red color and banana is the yellow color. So easily based on the color, we can discriminate. And shape also is easily described because the apple is the round shape kind of thing and banana is the some tall kind of shape is there. And what about taste? So I consider the only three different type of taste, sweet and bitter taste and sour taste. Can you tell me what is the taste of the apple? What is the taste of the apple? Sweet or bitter or sour taste?
Source.
No, apple.
Sweet, sir.
Sweet.
Sweet.
What about
Sweet.
banana?
Sweet.
Sweet. So if you chosen the color, shape, texture, this we can call as the properties or attributes or features. So depending on the which
Feature.
terminology features. So depending on the which domain or which terminologies you are using, based on that little bit variation is there in the terms. For example, who are the data mining people, they use the term is called the attributes. And remaining who are working on the image or video related kind of people, they will use the term is called the properties or features. Okay. So these are the properties or attributes or features. So suppose if you consider the your property or feature is the taste, so this only consider, then can you discriminate these two objects? It is possible. It's not possible because both are giving the sweet only. So if it is you taken the apple also sweet is there and banana also sweet is there, then based on sweetness we can't discriminate. So this is not important property. So we can always choose the important properties which give the more unique information among the within the class and more discrimination in information between the classes. So that type of the properties only we need to choose it. So in the machine learning, almost 60 to 70% of the your accuracy depending on the what type of the features or properties are using. Suppose your properties are not good, your features are not good, even though you are using best classification method or best clustering method, it won't give the good results. The reason is your properties are not good. For example, here this taste kind of properties you are using. So even though you are using the best classification method like support vector machine classifier or neural network classifier, it won't give the good results. Okay, so this is the important stage kind of thing. Okay, so maybe I'm not discussing about the other properties like text related or video related. I'm not discussing, just I want to go quickly on image related, then after that we can shift it to deep learning related kind of concept. So normally here I am discussing about the image. So you are seeing the one image that is called the binary image. So what is the binary image? Suppose I'm talking about the image. Image is nothing but the two-dimensional data. So two-dimensional data means it's contain the rows and columns kind of thing. Okay. So here you are seeing the some shape of the object. So what you are visualizing here? Person head plot or maybe brain kind of thing. How you are visualizing? On which basis you are visualizing the shape of the object? Based on the pixels. So each image consists of a pixels. Okay. So based on the pixels, we are visualizing the some shape of the objects. So what is the pixel? Pixel is nothing but the it consists of some value, that is the pixel intensity value or frequency value. We can call as the intensity value or frequency value. So based on the pixel intensity value or frequency values, we can visualizing the shape of the objects. Okay. Suppose my image size is 10 cross 10 is there. So it is the image means I said the two-dimensional matrix kind of thing. So total how many values is there here? But my image size is 10 cross 10. Total how many values is there?
100.
100 values.
100. 100.
Suppose here you can consider the your cell is the 1 pixel. So in this cell, how many values will be stored? Only one value will be stored. So what is the value? That is either 0 or 1. So 0 indicates the black color, 1 indicates the white color. So each cell contains the only one value, that is either 0 or 1, because it is a binary image. Binary image is consists of a only zeros and ones kind of thing. So then 0 indicates the black color, 1 indicates the white color. So for example, 0, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1, 1. So here where the zeros is there, that pixels contain the zeros means it's contain the black color, and where the 1 is there, it's contain the white color. Suppose in the second image you can see small portion is taken. Just extracting that portion means zooming that portion. Suppose if you are using the any MATLAB tool kind of thing. So in the MATLAB, one of the tool is there, that is the image processing tool is there. So when you are using that image processing tool, you can load the image. Then it is open that image with some pop-up box will come with the image. Just zooming that image. So you are zooming, zooming, zooming. Finally, what happened? So the shape of the object is disappear. Only the numbers will be appear. The numbers is nothing but the pixel intensity values. Okay, only numbers is there. Our point of view, we are seeing the some shape of the object, but computer point of view, we see the only numbers. That is the pixel intensity values. So after zooming, you can see the in the third image. So ones is there, zeros is there, because it is the binary image. So where the ones is there, it's consists of a white color. Where the zeros is there, it's consists of a black color. Okay. So now come to the point. So suppose if I use the my feature representation or feature vector is pixel intensity values based feature representation I'm using. Then can you tell me what is the dimensionality of the my feature vector of this 10 cross 10 image? So what feature I am using? Pixel intensity values. So what is the size of the my feature vector? How much dimensionality is there? So total how many pixels is there? 100. So that is first row 10 values, second row 10 values, third row 10 values. Total what is the size? 100 cross 1. So that pixels will be formed with the vector. So this is the feature vector for the my one of the sample. So like that in the database, total database 5000 samples is there, means 5000 images is there. So what is the total size of the your database? Feature size, feature database. How much dimensions is there? 100
High
cross
dimensions.
5000. So total number of samples 5000. Each sample contain the 100 dimension. So this is the binary image kind of thing. Next, you can go to the another type of the image, that is the grayscale image. So here grayscale image is not binary image, it is a binary image. Along with the binary image, it consists of some gray value. So what I said, it is also image. Image is nothing but two-dimensional data. So two-dimensional data is nothing but it is a matrix. So matrix is nothing but it consists of rows and columns kind of thing. Suppose here also you can assume your image size is 10 cross 10. So in this case also you can assume it each cell represent the 1 pixel. So in this pixel, how many values will be stored? Only one value only. What is the value? The value ranges from the 0 to 255. In this range values will be stored. So in that range values means what is the 0, 1, 2, 80, 81, 250, 251, 252, 253, 254, 255, like this values is there. So which are the pixel intensity values near to 0, then it's contain the black color. Which are the pixel intensity value near to 255, it's consists of a white color. And remaining the pixel intensity value depending on that one, it's contain that related gray value depending on the thickness of the gray. If it is more more gray color means it's more towards the 0, and less gray means it's towards the 255. Suppose if I selected one pixel here, can you tell me what is the pixel intensity value? How much? I selected a pixel here. So what is the color of that? White color. But I am not saying it is a pure white kind of thing. So maybe it is the near white means almost near to 255. So it is maybe 250 or something, or 240 or something. Suppose if I selected one pixel here. So what is the pixel intensity value here? It is a black color. So almost near to 0. Maybe it is the values 3 or something. Then if I select a pixel here, what is the pixel intensity value here? So this is very difficult to identify as a human because we don't know exactly value kind of thing. That is depending on the thickness of the gray color. So maybe it is towards the 0 or maybe towards the 255. So like this, each pixel can have one value. Suppose if I use the pixel intensity values as my feature representation, okay, then what is the size of the feature vector here for this image, 10 cross 10 image? So feature vector means you can convert this values into the form into the vector. What are the feature values is there that will you can form into the vector, that is called the feature vector. So what is the pixel values? Pixel values means how many pixel values is there in 10 cross 10 image? 100 is there. So this 100 values you can keep it to the vector. So that is called the feature vector. So what is size here also? 100 cross 1 for one image. Like this, for example, 3000 samples is there. Then what is the total of size of the your feature database feature vector is 100 cross 3000 or 3000 cross 100, either row wise or column wise you can take it. Okay. Now another type of the images which are regularly we are using, that image is called the color based image kind of thing, because everyone has the smartphone is there. So we are capturing the images with a smartphone, that is come with the color images only. So this is also image. Then image is nothing but the same thing, two-dimensional data. It's contain the rows and columns kind of thing. The image size also you can assume it 10 cross 10. So here also each cell considers a 1 pixel. So in this case, each pixel contains the how many values? 3 values. So what are the values? Red, green, blue. And each one contains the what is the value? The value ranges from the 0 to 255, 0 to 255, 0 to 255. Okay. Suppose if I selected one pixel from this image, so that I'm selected from the here. Can you tell me what is the here pixel intensity value? Any answer? If I selected one pixel from here, what is the pixel intensity value? So each pixel contains how many values? I'm audible?
Yes, sir.
Yes, sir, you're audible.
Audible,
Okay.
sir.
Okay. Thank you. So here each pixel contains the 3 values. What are the values? RGB. So here the pixel is not look like a red color. So it's not look like a red color means almost near to 0. Maybe it is a 4 or something. And it's green color. Maybe it is the 248 or something. And it is not the blue color. Maybe it is also small value near to 0. So these 3 color combinations, it is appeared as this type of the green color. Suppose if I select one pixel here, then what is the pixel intensity values in this flower? Because each pixel contains 3 values RGB, but it's not red, not green, not blue. So how it is appeared as yellow color? The 3 color combinations, maybe it is red is 30 and green is 45 and blue is 28. These 3 color combinations, maybe it is appeared as this color. Okay. Suppose if I use this pixel intensity values as my feature representation, then what is the size of the feature vector here? What is the dimensionality of the feature vector?
3
Of this
into 100.
Yeah, 3 into 100
100.
means 300 cross 1, because vector we can represent the cross 1. So how the 300 cross 1? Each pixel contains how many values? 3 values is there. Red, green, blue, red, green, blue. So that you take up to it's you. It's up to you. How first 100 is taken as a red color, next is the green, next is the blue. Like this 100, 100, 100. Like that you want to take a red, green, blue of the first pixel, second pixel, third pixel, like that. Okay. So like this you form your feature vector. Okay.
ଆମର ଯୋଉ ITC the 7th semester
So
ଥିଲା ଯେ
suppose
exam cyber security and privacy
here one image is there.
ପଡିଛି
Here one image is there.
ପଡିଛି
Here one image is there. So the image just what I said, you are zooming this image and again zooming the image, and after zooming you can get these values. Okay. Now based on these values, can you tell me it is the binary image or grayscale image or color image? So first you tell me it's contain the 1 value or 3 values. Each pixel contain the 1 value or 3 values. 1 value. It's not 3 values. Not 3 values means it's not color image. Now each pixel contain the 0 or 1s or 0 to 255 values. So here 237 is there, 239 is there, 87, 71 like is there. Means it's contain the 0 to 255. So it's not the binary. It's the grayscale image kind of thing. Now as we see the RGB means color image is there. So for example, this image size is 10 cross 10. Okay. Now each pixel contains the 3 values, red, green, blue. So all red values of this image separate and projected as a image. How the image look like is, the image look like what are the objects is there in the image. All the objects are appeared with the red color. So that is we can call as a red channel. Suppose if you separate all the green color pixels of that image and projected as a image after the separation, then how the projected image look like? Then all the objects are appeared as a green color. The same way, you can select all the blue color of the pixels in that image and projected that image. Then all are appeared as a objects will appear the blue color. So this we can call as a red channel, green channel, blue channel, or red band, green band, blue band. Okay. So normally how we can represent the images, height of the image and width of the image and number of channels. For example, three image cases we chosen our image size is 10 cross 10. Can you tell me binary case, what is the height, what is the width, what is the channel in the binary image case?
No channel will be there in binary case.
What is the height of the image?
Height will be 0 or 1. Like
No,
0 to
height is
5. It may
that
be
is
0.
no, height is different, pixel intensity values is different. The binary case pixel intensity values 0 or 1 means inside the image, but height and width is give the image size. So I already chosen all the cases 10 cross 10. So what is the height? Height is 10, width is 10, and number of channels is one channel. That's the reason each pixel contains the only one value. And in case of grayscale,
1. Channel number of channels will be 1.
height width
10 by 10.
same. 10 plus 10 plus 1.
10.
And what about color image?
3 into 3. Red, green, blue. Number of channels will be 3.
So this they will call as what I said, channels or bands. Okay, red channel, green channel, blue channel. So like that we can repeat the images like this, height, width, and number of channels. Okay. So for example, here image is there. So image consists of a pixel intensity values that I use the one more term that is called the frequency of the image. So you can plot that frequency into the graph. That graph we can call as the histogram of the image. So how to plot that graph? X-axis you can take the pixels, and y-axis you can take the frequency, means intensity value. So how much intensity value is there that you can take as a y-axis. So first pixel, how much intensity is there? Second pixel, third, fourth, like that. In image, how many pixels is there? That pixels you can take as a x-axis, and the intensity value is nothing but frequency value you can take as a y-axis. So you can put all the points together and draw the graph. So this graph we can call as a histogram of the image. Okay. So in initial days, in starting of the image, directly they use the pixel intensity values as a feature representation. Then after that they realized you can take the directly pixel intensity values, so sometimes it may not give better results as a feature vector. Then they will, instead of using the pixel intensity values, they will take in the pixel intensity values frequency count as taken as a feature vector. So how they form the frequency count? The frequency divided into the equal number of intervals. So for example, 0, 20 means 20 different frequency intervals they will constructed, 40, 60, 80, 100, 120, 140, like this 20 different kind of thing. So here for given image, so this is your image. How many pixels in this image contain the frequency from ranges to 0 to 20? Means how many pixels is there in the frequency of the 0 to 20? That count is taken. The count is taken. For example, count is 18. Okay. For example, 20 to 40, how many pixels is there in this frequency range? Okay. So maybe 20 to 40 frequency kind of total number of pixels 34 is there. And 40 to 60, how many pixels contain in this frequency range? Maybe it is contain the 48. And 60 to 80, how many pixels is there? Maybe it is 25. So like that pixel count is taken. So this count, using this count, they will form the feature vector like 18, 34, 48, 25. Like this, they will form the feature vector. Okay. So when they're using this as a feature vector, pixel count as a feature vector, that is given the better results than individual intensity values based feature representation. So this count, they will form the graph that is called the histogram of bin. It means this is 18, this is 34, this is 48, and this one is 25. So like this, they will form construct the graph. This graph we can call as the histogram of the bins. So each count what is forming the graph is called this is called the bin. So total diagram they will call as the histogram of the bin. So like that, like this they will construct the feature vector. So initially they will come up with the individual pixel values as a feature representation. Then later what they did, pixel count as a feature representation, frequency count as a feature representation. Now here I am showing the two different images of the fruits. It's not fruits, fruits, images I am showing, and ignore about this leaf. So one is a red color apple is there, another one is a green color guava fruit is there. Can you tell me, based on the color is nothing but what? Pixel intensity values. So based on the pixel intensity values, can I discriminate these two fruits or not? Fruits images or not? Any answer? Can I discriminate or not? Suppose you can draw the frequency graph. So the frequency graph for the apple I am drawing, red, green, blue. So it is look like a red color, then it's contain more frequency. When the green, blue places, it will come the less frequency. The same way, you can draw the frequency graph for the guava fruit. So red is almost 0, green is more, and blue also almost 0. Then you can compare these two histogram of images. Then how it is look like, both are same or different? Both are different. So both are different means we can easily discriminate. So based on the what color? Color is nothing but pixels, pixel intensity values. So based on that, we can clearly discriminate these two fruits images. Suppose here one red color apple is there and another one is the same red color. You can assume it's the same red color. Pie car is there. Now can you tell me, based on the color, can I discriminate these two images or not? Any answer?
No, sir.
So no. Why? You can draw
Sir,
the
color is same, pixel intensity will be same. But
Yeah.
you have to look into some other option or some other attribute to distinguish.
Yes. If you draw the histogram of these two images, the frequency graph, what will happen? Red is there, the red is more, and green blue almost 0. And here also red is there and green blue almost 0. Then you can compare these two histograms. How it is look like? Both are look like a same. Okay. So if both are look like same means both are the same related to same category. No, one is a fruit related, one is the toy related kind of thing. So how can I discriminate these two images? Then what type of the feature representation I need to use to discriminate these two images?
Shape.
Shape. Now color is not working, then we can go with the shape. So here shape of the apple is a round shape kind of thing, and the shape of the tie car is the different shape kind of thing. So for shape means then you need to extract the edge kind of information. So edge based information you need to extract. So in that case, some kind of filters is there. That is the Sobel filter and edge detection methods is there. We can extract the edge of the image. So based on that, we can get the shape and we can discriminate these two images. Next, another example I am considering. Here one red color apple is there. You can assume it same red color ball is there and same shape is there. Both are same shape. You can assume it. Now, can you tell me based on the color, can I discriminate? It is possible.
No, sir.
Because both are same red. What about shape?
No, shape
No,
is also same.
Round shape. And how can I discriminate these two images? Based on the texture. You can see the texture of the apple is different. The texture of the ball is different. Okay. So based on the texture properties, we can discriminate these two images. So what is the texture properties is there? You can apply the texture properties on image, extract the like energy, entropy, skewness, and mean, median. So like this, we can call as the GLCM features, gray level concurrence matrix. So these properties will be extracted on this image, and that you can use as a feature vector. Then based on that, we can easily discriminate the images. Okay. So here, what you see in color, shape, texture. So these are the different type of the feature representations. These are we can use to discriminate the objects. So now can you tell me each image contain the how many objects here? 1 or 2 or 3 or 4? Each image contain the how many objects?
N numbers of objects.
How many?
N. It may be N.
No. In this example, where I'm showing the example, each image contain the how many objects? So this is one image. How many objects is there? One. Here is one image. One. It is image.
One image is one object.
One object is there. So for example, you can assume it. I have the one image is there. Okay. So in this image, multiple objects is there. Many objects is there. Now you can tell me, based on the what you see in the up to now, these features like color or shape or texture, using can I discriminate these objects or not? It is possible or not? Just we can see the one example whether we can discriminate with this what you see in the color and shape and texture discriminate or not. So here in this first image, you can see the first image. So what you are seeing in the image, some vegetables is there. Okay, you can assume it which are the not available in this image. Vegetables also available. You can assume it. Many different type of the vegetables is there. Okay. Now can you tell me based on the color can I discriminate that vegetables? Is it possible? Based on the color, can I discriminate? It's not possible.
No.
Because mostly vegetable either green color, red color or something is there. And based on the shape, it is possible to discriminate?
No.
That is also not possible because some of the shape of the vegetable almost look like the same. And whatever based on the texture, can I discriminate?
No.
That is also not possible because texture of the vegetables almost same. But previously I shown example. So any one of the feature representation, either color or shape or texture is working, but here is not working. What is the reason?
Same category, all are vegetables.
No, if you take other things also, along with vegetables, you can take others also. The reason is previous case, each image contain the only one object, but here image contain the multiple objects. Okay. So here color, shape, texture, we can call as the global features. Global features means what? You are applying on entire image. Okay, you are applying on entire image this feature representation. That image contains only one object, then we can easily discriminate it. But here multiple objects is there, so we require the local features. So local features is the some different type of local features is there, and shift scale invariant feature transformations and surf speed of robust features and hog histogram of gradient features and binary robust independence elementary features. So like this type of the methods are available. Okay. So here what I need to conclude it, there is no single feature representation to satisfy the all different type of the data. It is not possible. Okay. So why? Because here you can see when you are using the local features, what they will do. So normally, for example, here I extracted a small patch, small portion of the patch. So that patch I given to you. So in this, what color is there? If I selected this patch, I given to you. So what color is there inside? inside the patch? Blue color, I'm right?
Blue color.
Same here, I'm showing the image. Suppose here this is the image. So here some patches is given, patches label A, B, C, D is given. Now, can you tell me the patch A, where I am selected? In the image, which place I am selected?
Right
Laptop.
side corner.
Corner. Here. I will say no, I am selected here. It is correct or not? If you say this one, no, I am selected here. If you say this one, no, I am selected here. If you say this one, no, I am selected here. So here this one match with the multiple places, I'm right? Same you can consider the B patch where I'm selected. This wall side.
Wall side.
Wall side also which position? I need exactly the position of the patch. Suppose if you say here, then I say no, I selected here. If you say this one, no, I will selected here. If you say this one, no, I selected here. So like that, it is also match with the multiple places. Suppose what about C? The roof of this above the wall like this. Suppose you can say this one, no, I selected here. You say this one, no, I selected here. If you say this one, I will selected here. And what about D? Here. If you say this one, no, I will selected here. So like that, it is also C and D also match with the multiple places. And what about E? Where I selected E?
Left side corner.
Specific location.
This one. Am right?
Yes.
What about F?
F is
Opposite of that one.
yes.
This one. So here I shown the A, B, C, D patches. So when you are saying the A particular place, I said no, I am selected here like that. I have given the multiple options I shown. But in case of E and F, it exactly match with the only one location, one place only. Because the what I am choosing the A comma B patches is related to the plane part. So plane will be not unique. It will be matched with the multiple kind of thing. And C comma D belongs to the edge. So edge also not unique. It is also matched with the multiple places. And E comma F is the edge corner orientation kind of places. So where the edge corner orientation is there, in that only it will give the more unique information. So based on that only we can easily identify the objects. So that concept they use in these local features. Okay, so based on that they will extract that points. That points they will call as the interesting points or descriptors. So based on that they will identify the object. For example, this is the image 1 and this is the image 2. Now I will show in the some particular places in the image 1. Can you tell me in that place any points are extracted in the image 2 or not? So for example, here I am showing the this round one. Here in this any points are extracted in the image 2.
ஏன்டா பவிக் சார் அவனோட அனுப்பியிருக்கான்
Are in this place. These two places, any points are extracted or not in the image 2. So where is the image 2? Here and here. Any points? Points means the round circles is there in the image 2. Like that, any extracted? No. What is the reason? These are the plane part. This is also plane part. Now come to the in the image 1. So between this orange color bell paper and red color bell paper, between this, in the image 2, any points are extracted. And here also the yellow color bell paper and green color chili kind of capsule kind of is there. And between these two, here any points are extracted in the image too? Here and here. Here also not extracted. The reason is these are the edges. Okay. So remaining places that is extracted points. So that based on that one, we can easily extract this interesting pointers or descriptors. Then based on that, they will identify the what is this subject. So that is the used in the concept is called the local features. So what I want to convey finally is, so there is no fixed kind of feature representations in the machine learning. These are the existing. Maybe you can come up with the better feature representations also. Okay, there is no fixed kind of thing. Maybe these features, even what I said, local features also not give the 80% or 70% accuracy. Maybe less than 80 will give. And you can come up with a new feature representation from your side. So that is the important, because why I'm talking about here is the feature representation is the one of the important stage in the machine learning. Your features are good, then only you can get the better accuracy. Your features are not good, then you will not get the better accuracy kind of thing. Okay, so like this you have the even feature representation also one of the research area, research topic in the machine learning. Okay, so it is clear. It is clear.
தாண்டி நினைக்கிறேன்.
Or any doubts? So you have any doubts is there, you can unmute and you can ask. Okay, anytime you can unmute and you can ask. So that is the given the some basic information related to machine learning. So what are the stages is there? One of the stage is the feature representation. So feature also have the depending on your data, different type of features is there. So I am not discussed about the other data related. Only I discussed about the image related. So image, what are the features is there? Color, shape, texture, and other than that, local features is there. So this is also not fixed kind of thing. Sometimes you can come up with a new feature representation also. Okay. Now, what is the thing is there in the, what is the difference between the deep learning and machine learning? Because this my talk is related to deep learning, so I will stop the machine learning related. Now come to the deep learning. So normally, what is the difference between the machine learning and deep learning is, so in the machine learning, what you are doing, you have the data is there. Next, you can extract the properties, that is called the feature representation. Next, you can give into the your model, means any machine learning algorithm you need to give. So like this, you have the stages is there. In the deep learning, what are the important stage in the machine learning is feature representation. Okay. In the deep learning, we are not extracting any features. We are not extracting any features. The feature extraction also take care by the your prediction model only. Our work is still simplified. What happened? We are not extracting any properties. See here. So conventional machine learning means normal machine learning only. So your data, next you are extracting the features. Next you are going to the prediction model, either support vector machine classifier or neural network classifier or any clustering method or whatever it may be. But if you come to the deep learning kind of applications, you have the data is there. We are not extracting any properties. Just to data give to the your prediction model. The model itself, it will extract the features and it will do the prediction. Both it will do. So this both take care by the your prediction model. Okay. So that is the difference between the deep learning and machine learning. You can see you have the input. For example, this is a car related image or car kind of thing is there. Then first you are extracting the features, properties of this car related to identify that is car or not. Then you can give to the your model, means your algorithm or any kind of thing. Then that will be detect either it is car or not car. So this is happened in the machine learning. But in case of deep learning, what will happen? You given the your data, here data is the car, given to the your model. This is the model. So model itself, it will be extract the features and do the both classification also, it is car or not. So this is the difference between the machine learning and deep learning concept. Okay, so it is clear. I'm audible?
Yes, sir.
Yeah, thanks. So what are the factors will give the discrimination among
Sir,
the
can you please repeat the difference between deep learning and machine learning?
So normally machine learning, some stages is there. First your data is there. Next you can extract the properties, that is called the feature extraction or feature representation. So what is the features? Just I given the some interaction related to the images. So once you are extracting the properties or features, you need to choose the your machine learning algorithm. So that is depending on the two types of learning methods is there. One is we can call as the classification methods. Another one is you can call as the clustering methods. So for example, now you are talking about the classification methods. So what are the classification methods is there? Maybe you listen to some words like support vector machine classifier or neural network classifier, like this is there. Then these features are given to the this classification method. So method will be based on the method, what will happen, it will train the model. Next you can give the test sample to this model, then it do the classification kind of thing. So normally this happen in the machine learning. So I said like this stages is that the important stage is feature representation is important. Why important? I said if your features are not good, then it won't give the good results. Now come to the deep learning kind of area. So here we take the data. We are not extracting any features. We are not extracting any features. The data given to the your deep learning model. The model inside itself, it will be extract the features and it will do the classification. Simply we can give the data, then it the model itself will do the features and model itself will do the classification. So we are not doing any manually feature extraction. Okay, so it is clear.
Yes, sir. Clear, sir. Thank you, sir.
Okay. So some other factors also give the discrimination among the deep learning and machine learning. So first factor is the data requirement. So how much data is required? So normally, suppose you people are already working on the machine learning, some of the people already knows what are the data sets are available. So where is the data is available? We can call as the repositories. So what are the repositories there? Maybe you already knows one is called the nowadays Kaggle is there, and previously the old one is the UCI repository is there. Okay. So these are the huge amount of the data sets of different applications, maybe text related, image related, video related, or any medical or any kind of data sets is available in the Kaggle. And UCI also some data sets available, but is not related to images. It is like a tabular kind of data, either categorical data or numeric data. So like that kind of data sets are available. So if you want to use the deep learning kind of algorithms, it's required the large amount of the data, means more data is required. Okay, more data is required. If it is the machine learning, you're using less data, small data sets also is enough. But here, if you're not using the more data, then what will the issue will come? What is the problem will come? So if you not have the more data, your model will be overfit. So overfit will be happen. What is mean by overfitting? Suppose you are running in the any algorithm, you are running multiple iterations or multiple approaches. So what will happen? After some approaches, it will be tuned your model, then it will give the better results. I'm right. So you are learning. What will happen? Initially you are learning, and after some days learning, any difference is there? Both are same. So after some days learning, you are expertise kind of thing. So you can do the same task in quickly and more effective way, more efficient way. So here also, first iteration you are running, you will get the 70% accuracy kind of thing. Even though you are running more number of approaches also, it will not change your output because it's already overfitted. So why it is happened overfitting is because of maybe your data variance is more. Okay. So variance means your data clarity is more is there at the time of initial learning only, it will be clearly learn, and it will, if you run more number of epochs, there is no change in the output. So that problem is occur in the deep learning if your data have the less data is there, but that is not happen in the machine learning. But you remember, even though less data is there, okay, deep learning give the more accuracy, means better results it will give compared to the machine learning. Even though if a data is less is there also, deep learning gives the more accuracy, but only problem is it is overfitted. Okay, so that is the first factor give the discrimination among the deep learning and machine learning. Next, another factor is the accuracy. Just I said now only, even the data is less also, which one is give the more accuracy? The deep learning give the more accuracy compared to the machine learning. Machine learning will give the less accuracy. So that is they used on many different applications, different type of the domains. They proved deep learning is giving the better results than the machine learning kind of thing. Only why machine learning is given less, deep learning is given means the way of extracting the feature representation are different from the machine learning and deep learning. So in the machine learning, we are extracting. Deep learning, the model itself extract and it will be generated learnable features. The learning features are generated. So that's the reason it is give the more accuracy kind of thing. Okay. Next, training time. So which one will be take more time, deep learning models or machine learning models? So definitely deep learning models will be take more time. Why? Because the way of extracting the properties or features is the extracting from the raw input pixels, from the extracting from the raw input pixels. Okay. So here it is take the more number of layers you're using. For example, if you are simple neural network. So what is there in the simple neural network? Either a multi-layer perceptron you can consider. If you know already in the multi-layer perceptron, so how it is look? Input layer is there, hidden layers is there, and output layer is there. So what is the input layer? For example, my data set is there, total 5,000 samples is there. In this 5,000 samples, each sample extracted 30 features. Okay. Then what is the input size? Anyone answer? I'm extracting 30 properties for the each and every sample. So what is the input size for this multi-layer?
Sure. So,
How much? The input size is what is the size of your feature vector. So what is the size of the feature vector? 30 cross 1. So the 30 values you can take as the input of sample by sample. Okay. Next, hidden layer 1, hidden layer 2, hidden layer, and I am given like this. So how many hidden layers I need to choose it? 1 or 2 or 3 or 4 or 5? How many hidden layers I need to choose it? So this is depending on your computational facility. Suppose you have the good computational facilities there, you take the more number of hidden layers. Because you are increasing the hidden number of layers, then what will happen? Time will be also, it will take more. Okay. So it is depending on your computational facility. You have the good machine is there, you can take the more number of hidden layers. If you have not have the good machine, then you can take the 1 or 2 or 3 kind of. Okay. Now, how many nodes I need to choose it in the hidden layer? For example, I concluded my machine is not that much computational facility. I concluded only 2 hidden layers. Okay. I chosen only 2 hidden layers. So in that case, then how many nodes I choose in the hidden layer? How many nodes I need to choose in the hidden layer? Any answer? The number of hidden layer nodes also optional. It's up to you. You want to reduce the dimensionality, then take the less number of nodes compared to your input size. For example, here 30 is there. I want to reduce the dimensionality. Then how many take? Less than 30. Suppose you don't want to reduce the dimensionality, you can maintain the same or you can maintain the more. Okay. Then you can take the more number of hidden nodes compared to the input layer size. Okay. So that is the how to choose the nodes in the hidden layer. And next, output layer is there. So how many nodes I need to choose in the output layer? So output layer, what will do? It will produce the output. What produce the output? For example, your task is the binary classification. So binary classification means how many classes is there? 2 classes. Then how many nodes I need to choose it? 2 nodes. Suppose my task is the digit recognition. So digit means 0 to 9 digits is there. Total how many classes is there? 10 classes. So total how many nodes I need to choose? 10 nodes I need to choose. Suppose my task is the 1000 class classification. So 1000 classes is there. Then how many nodes I need to choose it? 1000. So output layer is nothing but how many classes classification you are doing. So that many nodes you need to choose it. So this is the your neural network. So suppose you are using the more number of hidden layers, then they will call us the deep neural network. Deep neural network is not deep learning, deep neural network. And before input layer, add some more extra layers. Before input layer, add some more extra layers. Then how the architecture look like again? Deep or not? Before input layer, added some more extra layers. So then how your architecture look like? It is deep or not? Again it is deep. Already it is deep. You add the some more extra layers. Again it is look like a more deep kind of thing. That they will call as the deep learning. The some more extra layers added, we can look into the next. Okay, so already neural network is the machine learning algorithm, plus you added the extra layers. So this machine learning algorithms, which is the already machine learning classification methods is there, like other kind of Bayesian or any other kind of the things. Neural network will be take more time when the hidden layers are more. Then you add the extra layers, then what will happen? Definitely it will take more time. So the training time for the deep learning is more, and machine learning is less time will be take for training the model. Okay, so training time is for machine learning is less and deep learning is more. Next factor is hardware dependency. So now,
Hello, sir. Sorry to interrupt you.
yes.
Okay, sir. Is there any specific design criteria of neural network or deep neural network?
Specific criteria means?
Design criteria. Suppose if I wish to be perform some operation on the images or the videos or the categorical data sets, okay, and I wish to be extract some of the feature for that, or I wish to be go ahead without expecting some output of it. Okay, so is there any design criteria or design specifications are there so that I can design that?
See, design specification is nothing but it's not there. For example, your input is means your data is taking. How many hidden layers is required? You need to specify it. So you want a 3 or 4. See, number of hidden layers increasing. What will happen? Time will be take more. Okay. If your data is not that much of is there and more clarity is there, then what will happen? Maybe chances is there to overfitting problem also. Okay, so usually for 3-4 layers, if it's a small data set, you can use the 2 hidden layers or 3 hidden layers is enough, and remaining is the parameters are fixed kind of thing. Fixed means, for example, output layer, how many nodes you need to choose it. You can choose either depending on your class labels, how many class labels classification you are doing, and remaining what are the parameters is there, like weights, bias kind of thing, that are learnable parameters, means it will be tuned. It is not one time you are doing iterative times. Iterative time means it will go forward pass and backward pass. So every time it will update the weights and bias kind of thing, because the reason is initially you taken the weights and bias, it's a randomly chosen, it's not related to your data. Okay, so like that iterations you are doing, then it will tune that parameters, then it will be closest to the your data, then finally it will give the better results. Okay, so
okay, means user dependent, right?
yes,
Yes,
but
user
if you
can
have
choose.
that, you can choose. But if you come to the deep learning, some already models they developed and they build it. Okay, that you can use it, that I will discuss next. Okay, so hardware dependency. Now you want to run the deep learning algorithms where you want to run, and machine learning algorithms where you want to run. So suppose everyone have the most of the persons, they have the laptops or maybe desktop computers. So if you check your laptop or desktop computer, you have the processor is there. Each processor, how many cores is there? 4 cores, 8 cores. Okay. Suppose you have the program is there, you are running in this program, then what will happen? This program will be running on this 4 cores and maybe running on the 8 cores. Am I right? Suppose if you go a little bit bigger kind of thing, bigger means maybe in your college servers is there. Okay. So that server also contain the processor. In that processor, how many cores is there? Maybe 20 cores or 32 cores or 40 cores. So if you run the program, what will happen? It will running on this 20 cores parallelly. And if you run maybe 32 cores parallelly or maybe 40 cores parallelly. Okay. So like that is run. So this is normal machine learning algorithms. You can use it. It will run like this parallel kind of thing. Okay. Suppose if you want to use the deep learning algorithms, it is required the GPU based systems. GPU based. For machine learning, CPU based system is enough. Regularly, what you are using in the laptop desktops are belongs to CPU based, but is required the GPU based. So the one GPU based card is there. The card itself minimum nowadays 2,500 cores to the more than 7,000 cores are available in one card itself. That many cores is there. So it will run the not program run parallelly in variable level run in the parallel. Okay, not program level parallel, variable level it will run in the parallel. Even though that much course is there, that much parallel running is going on also, if to complete the task it will take maybe 1 day, 2 day, 3 day also. Okay, so that many powerful systems is nowadays available also. It will take more time because of the way of competition or way of extracting the properties. It will take more time. Okay, so definitely GPU based machines are required. Here CPU based machines. So now they will arise the question, suppose if you not have the GPU machine, then where I need to run the codes? So that is already cloud source for platforms are available. Some of them free source is available, some of the paid versions also available. So free is the like Google Colab is the one of the Google Colab is the one of the free source. So you can just go to the Google and type it Google Colab. It will be you can create your account, or maybe it is typed with your Gmail account. Okay, so that will be give the free competition kind of thing. So in that case, some limit free case, it have the limitations is there. Okay, so maybe how many hours you can use it, like 12 hours, how much memory, like 12 GB kind of RAM or 12 GB kind of GPU memory, like that they will provide. So after 12 hours, maybe it is discontinue. So it is running on the cloud. If discontinue, again it is you can't see the your results, or maybe you can't see the your data also. Okay, because that is in the cloud. So some paid versions is available. The paid versions Google also providing, that is Google Colab Pro, and Microsoft also providing, that is Microsoft AWS, and other private cloud sources also available. You can create your account, and depending on your usage, they will generate the bill kind of thing. So like that also you can use it. Okay, so these are the hardware dependency kind of things. These are the factors give the discrimination among the deep learning and machine learning. Okay, so it is clear. Any doubts? Okay, so no doubts, then I will go ahead with the next slide. So now we are talking about the deep learning kind of criteria. Who are initially developed these deep learning models? They choose the one of the standard data set. So everyone working on the data set and generate their results and compare with the already existing results, how their method is better than existing one. So what data set they use is, the data set name is called the ImageNet data set. So ImageNet dataset is freely available dataset. Just you can go to the Google and search with the ImageNet. So one ImageNet website will be open. So in that you can register it. It will be easily access your database. Okay. So what is contained this ImageNet database? It is contain the natural images kind of thing. General images. General images means what? Like flower related images and car related images and flag related images and cat related images. So like that, real time images are available. Total how many different classes is there means 1,000 classes is there. 1,000 classes means different type of the cars or different type of make of the cars or color of the cars comes to the one class, and different type of the computers comes under one class, different type of the flowers comes under the another class. So like this, total how many classes is there? 1,000 classes. So what is this task is 1,000 classes classification problem. Okay, so it is a classification problem. I don't know how many people already knows the basics related to machine learning, because I am not discussing that one. So normally classification problem and clustering problems is there. Okay, so classification problems we can call as the supervised learning algorithms. Clustering problems we can call as the unsupervised learning algorithms. So here, what is the difference between the supervised and unsupervised means? Only one simple difference they will say. Supervised means it is have the labels data. Unsupervised means unlabeled data. There is no label. It contains the labels means how the data is there. The corresponding label also provide in case of supervised. In unsupervised, only data give. For example, we are talking about the fruits related kind of a database like apple, banana kind of thing. So they've given the apple means this is what apple. So this is the label. This is your data. This is given in the supervised learning algorithm. Unsupervised, just they will give the fruit. There is no label kind of thing. Okay, so like that we have the labels and unlabels is there. Supervised means it is a label data. So here labels is there, but supervised algorithm we can talking about this one. It consists of a two data sets. One is we can call as a training data set, another one is the test data set. So both have the labels. So with the training data we can train the model. Same what I said the initially, you take the this data and extract the properties and give into the uh, machine learning algorithm. So that algorithm will be generate the model as the output. Next, we have the test data is there. This test data given to the model. Now you are testing it. This model will be generate the labels for the given test data. These labels we can call as the predicted labels. So already I said test data also have the labels is there. Then compare these labels and predicted labels. Based on that, you can quantify whether your model is perfectly working or not. So how to quantify different type of the metrics you can use it. So that metrics may be accuracy related kind of thing or error kind of thing. So this is usually is happened in the machine learning algorithms. But in case of unsupervised means unlabeled data. Unlabeled means it is only data is there. There is no training, there is no testing kind of thing. Only data is there. Okay, based on this algorithm, unsupervised algorithm, you can generate the labels for the this unlabeled data. You need to generate the labels for the this unlabeled data. Okay, so this is the difference between supervised and unsupervised learning algorithms. Okay, so now I said it is image. This is a classification problem. So ImageNet also what classification problem. So classification problem means it is contain the labeled data. So in labeled data means here two type of data sets is there. One is training samples, another one is the testing samples. So here millions of training images is there. Millions of training images means more than 12 lakhs images for training purpose, and 1 lakh images for testing purpose is there. So this is the huge database in the image related kind of thing. So everyone who are initial researchers developed the deep learning models, they use this data set and apply their algorithms and check the results and compare with the previous existing one. Okay, so this is one of the standard benchmark data set. So now here I'm showing the how the improvements came from initial to at before deep learning and initial stage of deep learning and after some days, some years. So here most of the people who are working on the ImageNet database only I'm projecting. So until 2010 and 2011. So these two are future engineering. Future engineering means machine learning algorithm plus they extracted features. So what type of the features they used? I said one of the feature representation in the local features is scale invariant feature representation, that is called the shift feature. And what are the machine learning algorithm? Support vector machine classifier. So this technique they applied on ImageNet database. So when 2010 they get the 28% of the error. So error is 28% means use, even 0.05 or 0.02 also it is used, means this is the 1 lakh images, 20%, 28% of images are misclassified. Next, even 2011 they use the shift SVM kind of approach. The error is only 0.2% will be reduced. Okay. Now from 2012 onwards, the deep learning model came. The deep learning model we can call as a convolution neural networks, CNN. Simply form they will call as a CNN, convolution neural network. Okay. The first model they built in 2012. So the 2012, what is the first model built? They applied on this ImageNet data set. The error is decreased to 0.6%, 0.16 means 16%. So almost half of the error is decreased. Then 2013, they did small modification on previous algorithm and applied on the same ImageNet dataset. Again, it will be reduced to 12%. So again, error is reduced. Again, 2014, one more deep learning model algorithm, another modified convolution neural network algorithm built. So that is reduced to 12% to 7%. So like that, every year they will come up with some algorithm modified and they reduce. So finally they will reach to 2% error kind of thing. So like this, lot of improvements came, and presently still it will reduce also because of the advanced technologies like chart GPTs related LLM models came. So still lot of improvements is coming. Okay. So like that, the revolution came from the basic machine learning to the deep learning. So how the better results is approached on the ImageNet dataset, this graph is showing. Okay. So this convolution neural network, first deep learning models, they applied on the different domain and different area also. It's not only image kind of related kind of images, also not only natural image. They apply for the medical domain also, and remote sensing related data also, and video data also, bioinformatics also, many different places they applied, and many publications they published. So here only I taken the old data, this long back until 2015 only. So how the publications are published in different areas. So that I'm showing in this graph. And in the algorithm point of view, in the methods point of view, variations also came in the deep learning models. So I said initially what are the models is the CNN models is the convolution neural network models. Then after that, to go for sequence data kind of applications like RNN, recurrent neural network, and LSTMs, BiLSTMs, transformers. Nowadays LLMs you can call as that is also comes under the transformers only. So like that, lot of variations came. And here CNNs you use it for the labeled data kind of thing. Suppose if your unlabeled data is there, what type of the techniques you can use? Autoencoders you can use it. Okay. Like that, a lot of variations, algorithms also coming year by year, and lot of improvements and coming, and better accuracy showing compared to the initial stage algorithm to the current nowadays which is available algorithms. So up to here it is clear. Any doubts?
No, sir.
Okay. So here I'm showing the one image. What is the number you are seeing? The number is 8. So how it is visible that 8? Already in the beginning of this session I told. So you are visualizing the some kind of object, means based on the pixel intensity values or frequency values, we are only visualizing the object. So the front we are seeing the shape of the object, but background what is there? Only numbers is there. This numbers is what? Pixels or pixel intensity values. Okay. So the same way we are seeing the objects. For example, here 3 small dogs is there, puppies is kind of is there. We are visualizing, but computer point of view, what will see? The pixel intensity values only it will see. Okay. So How to identify the objects? One of the ways you can use the edge detection algorithms to identify the objects. Okay. So for given image, what are the objects is there? Like persons is there and bicycle is there, like that kind of objects is there. Then how to identify means one of the ways edge detection method. So here edge detection means the shape of the object will be displayed, but what type of the edges, what different type of the edges is there. So some edges we can call as the vertical edges, some edges we can call as the horizontal edges, some edges we can call as the diagonal edges also. What is the difference? For example, in this image the person is there. So if you are using the vertical edge kind of information, so you need to extract the vertical edge related means the persons will be or any object will be represented with the vertical lines, like this vertical edges. The person will be represented with the vertical, or bicycle is there, the bicycle will be represented with the vertical lines. So this is all vertical lines. Suppose you are using the horizontal edge kind of information you want, then what will happen? The person will be represented with the horizontal lines, and bicycle also will be represented with the horizontal lines. The lines is nothing but edges. So like this horizontal edges or vertical edges will be represented. Maybe you can, I am not sure, it is clearly you can watch it. So it is of initially image is extracted for the this input image. So here vertical edges in extracted, you can see vertical lines kind of thing is there. All are represented with the vertical lines. Then in below image, it is the horizontal edges kind of thing. You can see like this horizontal edges is there. Okay. So like that, different way of extracting the edge is there. Then how we can extract this edge information? Okay. So that is the question. To extracting the edge information, here the one kind of techniques is there. So for example, this is the your input image, you can assume it. Input image. So what is the size of the input image? 6 cross 6. Okay. My image size is 6 cross 6. And we have the one image is there, that is called the here one filter is there. The filter size is 3 cross 3. Okay. So the filter size is 3 cross 3. So filter is nothing but is the small matrix of size 3 cross 3. So total how many values is there? 9 values is there. Okay. Now the filter will be convolved with the corresponding image pixel values and take the sum of all the values and produce that output value. So like that you can do for the entire image. That output you can project it as a image. That image look like a edge information. So what I'm saying, each filter values. So what is the filter value? 3 cross 3. The same image pixel value can select same image pixel value of size 3 cross 3. Okay, these are 3 cross 3. And what is the corresponding filter values? For example, in this place 1, 1,
Thank
1,
God. ఇప్పుడు కనెక్ట్ అయ్యింది
0,
ఇట్లా
0,
ఎందుకు కనెక్ట్ అవ్వట్లేదా
-1, -1, -1. Now the image pixel values are convolved with the corresponding filter values. Okay, so what is the first pixel value? 3 and corresponding filter value 1. Take the sum of all the values, and next image pixel value 0, filter values 0, plus image pixel value 1 and filter value -1. So first row completed, and we are taking the sum of all the values. Then second row started. Image pixel value 1, filter value 1, image pixel value 5, filter value 0, image pixel value 8, filter value -1. So second row values completed. Next come to third row. Image pixel value 2, filter value 1, image pixel value 7, filter value 0, image pixel value 2, filter value -1. So image pixel value convert with the corresponding filter value and take the sum of all the values. So here what is there? 3, and this is 0, and this is -1, this is +1, this is 0, -8, and 2, this is 0, -2, -2 +2, -1 +1. So what is the sum of the values? -5. So -5 is the first output of the convolution operation. Next, what you need to do? filter is moving one step forward. So it will be move one step forward from left to right. So now where is the position? Here. Again, the filter size is what? 3 cross 3. Then you can select the same size of the image pixel values. Then now convert the image pixel values corresponding filter values. Take the sum of the all the values. Same way. So after sum of the values, maybe you can get the value is 3 kind of thing. Maybe 3 getting means that is the second output. Next again that is our output is getting. Next again filter moving one step forward. Again select the same size of the image filter values 3 cross 3. Convolve with the corresponding filter values. Okay. Then that is after that maybe you can get the values 2 or something. Then again move the one step forward. Convolve the image pixel values with the corresponding filter values and take the sum of the value. Maybe it is -1. Then left to right is completed. Next what you do? Come from the top to bottom, means again the first row skip it and you can select the second row onwards. Again the same size of the filter size 3 cross 3. Again the convert the filter values with the image pixel values. Again move left to right. So second row will get like that, third row, fourth row. So now you are getting these values. These values you can project it as a image. So this image contain the what? Edge information of your original image. Edge information of the your original image. So what type of the edge information you can get? That is the question. That is depending on the what type of the filter you are using. Your filter is vertical edge related filter, then your edge information contain the vertical lines kind of thing. Suppose your filter is a horizontal edge related kind of filter, then output image consists of a horizontal edge related kind of information. Okay. So now for example here vertical filter they're using, then you get the output projected, then it consists of a vertical lines of the image. Okay. So it is clear. Any doubts? How the edge information extracted here? If you have any doubts is there, you can ask. Otherwise, I will go forward. So like this, some of the filters already existed in the machine learning or image processing kind of applications. See, normally our real time also we are using the filters. Everyone knows because everyone has a smartphone is there. So mostly after taking your photos, most of the people they use the filters to convert your original taking photo to some of the modifications they will do. So that how you are doing using the filters only. You are applying the filters like you want the grayscale kind of image, or you want the more color or more squeeness, means more soft kind of your face related kind of thing, or coloring kind of thing. So that filters you are applying. So that is the predefined filters kind of thing. So like that in the machine learning or image processing, some filters is there. So here I am showing that these values are fixed kind of thing. Suppose you want to extract the edge related kind of information, you can use this kind of values, or maybe you can sharpen in the image, you can use this filter, or you can blur the image kind of thing. You can two type of blurs is there. One is a box blur, another is Gaussian blur is there. So you can apply this kind of filters, then your original image is converted into the blurring kind of thing. Okay. So these are the already available filters. Okay. Now we are we are going to the convolution neural network. How is this convolution neural network related to the edge related? Almost all are the same related kind of properties only. So why are the CNNs? CNNs is nothing but the convolution neural network. Why the CNNs are required? The CNNs, convolution neural network, are the extracting the invariant feature representation from the raw input pixel data. Okay, it is extracting the more robust. The features are more robust. Invariant feature representation extracting from the raw pixels. So that will be helpful for the many different applications like classification related, object detection related, or segmentation related. So that's the reason nowadays this convolution neural network are more popular compared to the machine learning. So it is extracting the more robust invariant feature representations that are learnable feature representations. Okay, extracting from the raw pixels input data. Okay, that's the reason these are the more popular. So what type of the convolution neural network is there? So basically convolution neural network not have any types. It is the only one type, but little bit people understanding point of view, they give the types kind of thing. But it's the only one type only. So normally normally when they're developing the initial convolution neural network model, so that is applied on the images. Okay, they build the convolution neural network on the images. So image is what? Two-dimensional. Okay, it is a two-dimensional data. So in this case, the what I said, the filter also, it is look like a matrix only. So here they use the term filter or kernel. It is not OS kernel. Here also this filter also called as a kernel and weight matrix. All are same only. These terms all are same. Filter or kernel or weight matrix. These all are same only. Filter is nothing but, or kernel is nothing but, a weight matrix is nothing but a small matrix. Okay. So here my input is image. So image is nothing but the two-dimensional data. So your filter also two-dimensional data. This filter or kernel, okay, is moving two directions. This kernel or filter moving two directions. So how can I move? Is move left to right and top to bottom. So the filter is moving two directions, means left to right and top to bottom. Then that is called the 2D CNN. In this case, kernel is or filter is moving two direction, left to right and top to bottom. Okay, so that is called as the 2D CNN. But in the days, my data is the not two-dimensional data. My data is the one-dimensional data. Then how can I use it? One-dimensional data, how can I use it? One-dimensional data, what is there? For example, your data is the signal-related data. Signal is the one-dimensional data. Suppose you are using the text documents kind of thing, you are extracted the properties, features. So features is nothing but the feature vector for the each sample. So that is also one-dimensional data. So in that case, how can I use this convolution neural network? So initial stage, how they use the convolution neural network for this one-dimensional data is, so for example, one-dimensional data is 100 cross 1 is there. Okay, so this 100 cross 1 reshaped, resized it to 10 cross 10. Now it is look like a matrix. Then apply this filter on this one. Then in this case, filter moving two directions. So that one-dimensional data converted to two-dimensional. But it is a 10 cross 10 is there, is okay, fine. For example, 98 cross 1 is there. Then how it will convert into 10 cross 10? It is not possible. So where is the insufficient value samples is there? That they will consider as the zeros. Then it is 10 cross 10 matrix it will form. Then again the filter will apply. The filter is moving two directions. Okay. So like this initial stage they used one-dimensional data, convert into a 2D dimensional and they used. But after some days, they will build the one more CNN is called the 1D CNN. 1D CNN means, so your data is one-dimensional data, is a vector kind of thing. So in this case, your filter also one dimension. So in this filter is the one dimension means what? It will move only one direction because your data is one direction, one dimensional. Then filter also move only one direction. Then they will call as the 1D CNN. Okay. In that case, filter is moving only one direction. So in that case, there is no need to resize it, reshape it. Just they will take the one-dimensional filter. The one-dimensional filter is moving only one direction. Okay. That they will call as a 1D CNN. Some other type of the applications is there, some other type of the data types is there, like medical data like MRI images kind of thing or other CT scanning kind of images. They have the one type of the images that is called a dichroma images. So dichroma images means it is like a slicing kind of images. The sequence of images with slicing is there. So in that case, how this convolution neural network they will apply. So how that image look like? dichroma images. First, for example, one image is there. So it consists of a sequence of slices of images like this. Is like a 3D kind of thing. Slices of images is there. Okay. So in this case, what will happen? The filter is moving left to right and top to bottom. Along with the left to right and top to bottom, it's go to the this slice to the next slice from this direction also. So it's moving 3 directions, left to right and top to bottom, along with from moving from this slice to the another slice, that direction also moving the filter. So in this case, it is the filter or kernel is moving 3 directions. Then they will call as a 3D CNN. Okay. So they will call as a 3D CNN. So like that, they will give the category the type of the CNN, but originally initially developed for the, on the image, that is called the two-dimensional data. So that is the 2D CNN only. Okay. So I said already why we are using convolution neural network, because that is providing the robust good in learning features kind of thing that is developed from the raw input image pixels only. Okay, so that is the more better feature representations are giving compared to the traditional feature representations, and they applied in many different type of applications like classification, recognition, segmentation, many different kind of applications they're using. So I said how to represent the image, height of the image, width of the image, number of channels, 3 channels. So red, green, blue kind of thing. This is the image representation. Okay. So you have any doubts is there, you can ask.
Sir, can we take every time 3 by 3 filter only or any other size we can take?
Any size you can take it. That also I will discuss next slides.
Okay, okay, sir, thank you.
So yeah, yes.
Hello, sir.
Yeah.
Can you please explain how this CNN works for audio type of data?
So
Speech
audio
kind.
type of data is a speech. Speech is the signal. Signal is the one-dimensional data. Am I right? So normally in one-dimensional data, what they will do, like this continuous waveform kind of is there. They fix the window mechanism, some size like window kind of size. So in this window, they will extract the some kind of properties that is called the MFCC features, smell frequency, spectral coefficient values. So that is the vector representation. So like this, see how the form the vectors. So it is a one-dimensional data. Then one-dimensional data means one-dimensional kernel, they will use it. Okay. So one-dimensional data, one-dimensional kernel means I said it is only move one direction only. Okay. So it is a continuous data kind of thing. Other kind of approaches also available for continuous data, like recurrent neural networks and LSTMs, BiLSTMs also available. Some other kind of techniques also is there. LSTM, BiLSTMs also is there.
Okay.
Okay. Yeah. So here what I'm showing is that this is the convolutional neural network architecture. Basically here 3 different type of the layers is there. One is we can call as the convolution layer. Another one is we can call as a pooling layer. And final one is called the fully connected layer. So these 3 layer combinations we can call as the CNNs. So you can see here input image is there, and here the convolution and pooling layers is there, and finally fully connected layer is there. Just you can see, you can observe it. I will clearly discuss about the each and every layer in more detail kind of thing. Just I will take the 10 minutes break. So now it is 8 o'clock. Then I will come back 8:10. Okay. Is it fine?
Okay, sir.
Yes, sir. Yes, sir.
Yeah.
Hello.
Hello.
Sir, please mute and then speak, sir. Not audible. Sir, unmute.
Sir, please unmute. It is not audible, sir.
Sir,
So now my screen is visible.
Yes, sir, it is visible.
yes, sir.
Yes, sir.
Yeah, fine. So basically it consists of 3 layers. One is convolution layer, pooling layer, fully connected layer. So here you can see below diagram here first convolution operation you are doing. So what you're after convolution operation, what you are getting the output, they will use the term is called the feature maps. Okay. Then after that they apply the pooling layer, that is called the here showing the subsampling kind of thing, that is the pooling layer. So initial convolution model, the convolution layer and pooling layer like alternative kind of thing. Okay. Then finally have the fully connected layer is there. Then we can look into the each and every layer, what is the functionality is going on, what are the parameters we need to use it, that we will discuss now. So now first one is the convolution operation. Okay. So convolution operation almost same as I previously what I discussed, the edge information extraction. So here also you can consider the your image is that is called the image size of 4x4. This is your input image kind of thing. Okay. So I'll select the one filter or kernel of size 3x3. The same way how the edge information is extracted, the same way here also we do the same operation we can perform on the input image. The filter will be same operation it will do. So how the convolution operation will be performed means how the feature map will be generated. The current layer feature map, for example, your health layer feature map. Okay, health layer feature map. How it will be generated? The previous layer feature map, the previous layer output. So previous layer means what? L minus 1 layer. Convolve, multiply with the current layer filter. Okay, and this summation I comma j. Apply the activation function. So this is nothing but the your convolution operation or feature map. So current layer feature map. Current layer feature map means your convolution operation how you are doing. The previous layer feature map convolve with the corresponding filter. Okay. And here one more thing, we can add the bias and apply the activation function. So normally if you know neural network, so what type of the operations you are doing the hidden layer nodes and output layer nodes, the same operation this one only. So what is you are doing the hidden layer nodes and output layer nodes? Each input multiply with the corresponding weight and add the bias. Okay, each input multiply with the corresponding weight and add the bias. Then after that you are applying the your activation function. So this computation is going on each and every hidden layer node and output layer node. The same way here also. So the previous layer feature map is the current layer input. Convolve with the corresponding filter value. Add the bias, then apply the activation function. So that is the current layer output, that is can called as the feature map. So same here. The filter size is 3x3. So previous feature map is this 4x4. So what is the filter size is the same size of the image pixel values, you can select it. Okay, so that is 1 0 0 0 0 1 1 0 0. Then image pixel values are multiply, convolve with the corresponding image pixel values. Okay, and take the sum of the all the values. So that is what is the here that will get. So that will get the 2 cross 1 plus 0 cross 0 plus 1 cross 1. First row completed. Next second row 0 cross 0 plus 1 cross 0 plus 0 cross 0. So second row also completed. Next come to the third row 0 cross 0 plus 0 cross 1 plus 1 cross 0. So this is 2, this is 0, this is 1, 0, 0, 0, 0, 0, 0. So all are zeros. Okay. So 2 and 1 is there. 2 plus 1. What is the value? 3. So the 3 is the current output. Okay. So now the first place come to the 3. Next, what will happen? The filter is moving one step forward. Okay. So after moving one step forward, then again it will do the convolution operation. Means it will again convolve the image pixel values with the corresponding filter values. Okay. Then what the value you can get it? So here this is 0 into 1 0. This is 1 cross 1 1 will get, and here all the zeros is there. This all the zeros convolve with this one 0, and here this one. So this is there 1 plus 1, here 1 plus 1, here 1 will get 1 plus 1 2. So next output 2 will get. So left to right is completed. Next what will happen? It's move from the top to bottom, means it will skip the one row and start from the next row onwards like this. Then again this image pixel values convolve with the corresponding filter values. So here 1 means it is 0, and this 0 into 1 0, and 1 into 0 0. So these all are zeros, these all are zeros, and this 3 and this one is there. So what will get again output? Next again filter is moving one step forward. Then here this image pixel values convolve with the corresponding filter values. So this one multiply with this one 1, and this is 0, this is 0, and zeros, all zeros. Then finally you can get the this is the one. So this is the after convolution output is this one. Okay, this is the convolution output. They will call as the future map. Okay, so you can see 3 2 3 1. Okay. So like that you can do the convolution. This is the convolution output. They will call as a feature map. So here you can clearly observe it. What is my input size? 4 cross 4. And what is my filter size? 3 cross 3. And what is the output size? 2 cross 2. So how will calculate this input size and output size is? So that will calculate it with the input size minus filter size. Okay. Plus bias 1. Okay, plus bias 1. So input size is what? 4 minus filter size is 3 plus 1. What happened? 4 minus 3 1. 1 plus 1 2. So 2 cross 2 is the your output size. Okay, so this is the output size calculation. Up to here this formula you can follow. Later I will tell the small modification in the output size calculation. But here the two drawbacks is there when you are doing the convolution operation. So what are the two drawbacks? The first one is, so it is not doing one time convolution. You are doing multiple times convolutions. I'm right. Convolution pooling layer. I said alternative kind of thing. So when you're doing the multiple times, then what is going on? For example, it is of a small size. You're seeing 4 cross 4 converted to 2 cross 2. For example, your image size is 220 cross 220 is there. Then what will happen after convolution operation? It will reduce size. Again, one more time convolution operation, again reduce. Again convolution operation, reduce. So like that, you are applying some sequence of convolution operations on your input data. Then finally, your what will happen? The image size is input size is degrading, means is shrinking, is reducing. So the input size is shrinking problem will come. That is the first issue. Second issue is you can clearly observe it. The corner pixels are not involved multiple times in the convolution operation. Suppose your important information is there in corner pixels, maybe chances is there to lose the information. Why? It is not involved multiple times in the convolution operation. Now can you tell me this one and this one and this one and this one, how many times involved in the convolution operation? One time or two time or three time? Any answer?
One time.
Only one time only. The corner
Only
pixels
one.
are one time. Suppose our important information is there in the corners of the image, then it will not properly extract. So maybe your information loss will be happened. So these two problems will be raised in the convolution layer. Okay. And when you're doing the convolution operation, you need to prepare the some parameters. You need to take the some parameters. So that what are the parameters we need to consider here? I will discuss. So first parameter we can call as the stride variable. Okay. See here. So our filter is moving on entire image left to right and top to bottom kind of thing. So first variable I said the stride variable. So what is the stride variable is? Stride variable is nothing but it is moving the your filter either forward direction and top to bottom. So how many steps I need to skip and move forward, that will be decided by the stride variable. If the stride equal to 1, so every time an entire image from the left to right and top to bottom, it will be move one step forward only. Means once convolution operation is completed, it skip the one row or one column, move forward. Suppose if a stride equal to 2, means after the first convolution completed, for example, first convolution your filter size is 3 cross 3. So 3 cross 3 means like this image pixel values will be selected. You do the convolution operation and take the sum of the values. Then first you are getting the output size is 108. I'm right. Then after the convolution operation completed, what it will do? It move one step forward. But here stride equal to 2 we taken. Stride equal to 2 means how many steps I need to move forward? Skip the 2 columns and start from the here. Again 3 cross 3 you can select. Okay. So now again this 3 cross 3 green color matrix convolve with the corresponding filter values. So once convolution is completed, then again it will be skip the 2 columns. Again you can select the this 3 cross 3. So like this it is also do the convolution operation and you can get the some value, for example 38 or 138 kind of thing. So left to right is completed. Next left to right completed, then what will happen? You come top to bottom. So when you top to bottom coming, how many rows I need to skip? 2 rows. This one I need to skip. Again select the this one. Then this, what are the 3 cross 3 image pixels convolve with the corresponding filter values. Once filter values convolution completed, take the sum of the values. That output is this one, 288. Then again this convolution operation completed. Again skip the first 2 columns. Next is start from the this 3 cross 3. So again convolution you can get the 3 cross 6. Then this completed. Again skip the these 2 columns. Again you select the this 3. Again left to right completed. Next come top to bottom is already first 2 rows skipped. Next third row, fourth row you need to skip and start from the here. This one. So like that is moving the entire image left to right and top to bottom. But once convolution operation is completed, it will skip the 2 rows or 2 columns. For example, I chosen the stride equal to 3. Okay, my stride variable equal to 3. Then first convolution is completed. Okay, then next where I need to start? So I am giving the my row values and column values like this: 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7, 8. Okay, first convolution completed. Next where I need to start? Any answer? So first convolution means this 3 cross 3 selected, completed. Next to where I need to select, where I need to start, means I move to left to right. So where I need to select, which column I need to select?
Fourth column.
Fourth column, because I need to skip the 3 columns and start from the here. For example, left to right completed. Next come to top to bottom, where I need to start? Next convolution operation.
8.
Which one?
8 one. But
Fourth
not
row.
possible.
Fourth row. Because stride equal to 3 means 3 I need to skip, start from the here. Again move left to right like that. Okay. So every step, how many rows or how many columns I need to skip it. That is decided by the stride variable. Okay. Now stride variable is there. Then what is the size of the output shape? That's still remaining same? No. Is depending on the stride variable, your output size will be changed. Okay. How it will change? So what is the previous case? What I given the equation? Input size minus filter size plus 1. But here divided by the stride variable is there. Previous case stride equal to 1. That's same reason I'm not told the stride variable here. But stride variable more than 1 is there, then it will be changed. Okay. So always this value you can round up to the up to the value, means upper values too we can round up. So input size minus filter size plus 1 by stride variable. Okay. So this is a stride variable. See here, you choose.
Sir, you are muted. You're not audible. Srinivas, sir. Hello, Srinivas, sir. You are muted. You're
I think someone is muting. I'm audible now.
Yes, sir.
Yes,
Now
sir.
you're audible.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. So you can see here stride equal to 1. So every step, one step move left to right and top to bottom. Okay. Now observe stride equal to. So my filter is moving left to right, and every movement it will skip the 2 rows or 2 columns in the second image. Okay. So this is the stride variable. Next, another parameters we need to set it. See here, the filter is moving. If the stride equal to, in this case, stride equal to 1 and kernel. So every time calculation is going on, then you can get the future map. So here stride equal to 1 means I said input size minus filter size plus 1 by stride equal to 1. Okay. So like this entire image, your filter is moving, then you can get the output is the future map. So now here some kind of structures I am taking and look into that. For example, first convolution is completed and stride equal to 1. Then next one is start from the, for example, here I am taking the columns names like this. Okay. So next one start from the first column onwards after the first convolution completed. Suppose if stride equal to, where it will start after the first convolution operation completed, which column it will start? From the second column. So first convolution completed, next is second column, because stride equal to means skip these 2 columns. Suppose first convolution completed, my stride equal to 3. Start from which column? My filter size is 3 cross 3. First convolution is completed. Okay. Then next stride equal to 3 means in which column onwards it will start? Second column or third column? Third column. So third column is my image is up to here. Then my filter is came out of the image size, because 3 cross 3 is the filter size. Okay. Then came out of the image size. Image is up to here only is there. then convolution is possible or not? The convolution is not possible because my filter is came out of the image size. So in this case, how to solve the problem is you need to set the another parameter that is called the padding. So they use the term is called the zero padding. Okay, so zero padding. So padding means padding equal to 1 means it will be add the zeros to the all the sides. All the sides means here, 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 here. For example, my input size is 5 cross 5. Okay, then I'm adding the padding equal to 1. Then what is the input size will be changed? How much dimensionality?
6
7
cross
cross
6.
7 cross 7. For
7
example,
cross
padding
7.
equal to 2. Then what is the size of the dimensionality?
9 cross 9.
So 9 cross 9. So now we can where the kernel came out of the size of the image, then convolution is not possible. Then we can use this parameter is called the zero padding. So now add the zeros to all the sides. Now convolution is possible. You can see now is convolution is doing. So here you can check the filter is come to the out of the size because zeros is there. Then it do the convolution operation. So that you can call as the zero padding. Okay. So this zero padding solve the two issues faced with the convolution operation. So what are the two issues? First one is the image shrinking problem. So like this, you are adding the zeros, then what will happen? The output size is same as the input size, you can get it. The output size same as the input size, you can get it. For example, my input size is 5 cross 5. Okay. And filter size is 3 cross 3. And stride equal to 1 I am using. Then what is the output size? What is the output shape of the output of image after the first convolution? How much size you can get it? Input size
6 by 6
minus filter size by stride equal to 1 and plus bias 1. So what is the value? 5 minus 3, 2. 2 plus 1, 3 cross 3 you can get. Okay. So here output size is reduced, means shrinking is there. For example, I'm adding the padding equal to 1. Then what is the input size now?
7 cross 7.
7 cross 7. Same filter I am using 3 cross 3, my stride equal to 1. Then what is the output size now? 7 minus 3 by 1 bias 1. So what is the value? 5 cross 5. So what is the original input size? What is the output size? Both are same or not? So you're getting the output size is same as a input size. But is always is true? That is not always true. Depending on the your stride variable, your stride is changing. Now stride equal to 2 you can give. What will happen? 7 minus 3 by 2, 4 by 2. 4 by 2 means 2. 2 plus 1 means 3. 3 cross 3. Now 3 cross 3 is same as the original size? No. In that case, you can increase your padding size. Padding 1 is not possible. Padding 2 or padding 3 you need to go. Okay. So like that you can adjust the padding. So the image shrinking problem will be reduced with this padding. First problem solved. What is the second problem? Corner pixels are not involved multiple times. Now you can tell me this pixel is involved after zero padding. How many times it is involving? More than one time or not? It will involve multiple times. For example, one time here, another time here, if it's stride equal to 1. So like that left to right you can move and one more time here and one more time here. So it is involved the multiple times if you are using stride equal to 1. Okay. So that corner pixels issue also will be solved with the zero padding. So this is one parameter you need to set it here. Okay. So one is stride variable and another is the zero padding kind of thing. One more parameter is there that is called the depth. Okay. So depth is nothing but For example, if it is color image, what is the depth of the color image? What is the depth of the color image? I said depth and channels is same. Depth and channels and bands are same. Okay. So if it is color image means how many channels is there?
3 channels.
3 channels.
3, sir.
So for example, if it's a normal image, means like a grayscale or binary image. So one time you are doing the convolution operation, means one convolution operation doing on with this filter, then what you are getting, one matrix as the output you are getting on future map. Okay. Now if it is a color image, so color image means how many matrices is there? 3 channels. So this filter is convolved with this red channel, this filter is convolved with the green channel, this filter is convolved with the blue channel. Then how many outputs matrices you can get? 1 or 3?
3.
So 3 you can get. So this is the depth is what? 3 here. Okay. Depth is 3. Now.
So this is only for color images.
Which one?
This we had applied depth only for the color images.
Not color. Any images can apply. For example, I give the one outcome. So my output image size is input image size something is there. Okay. Then I give the output image. For example, not like this. The output size image after convolution, my output size is like this is there. Okay. So what is the depth here?
Sir, in case of grayscale, the depth will be 1, no, sir? Because you don't have the RGB channels over there. So
Okay,
either
depth
it is black or white. So it will become
yeah.
1, no, sir?
Yeah, that is 1. But in case of color image, you are saying the 3. But I given the here one dimension 128 cross 128 cross 96. So what is the depth here? How much depth?
8 cross 96.
So you are getting this output means 96. The depth is 96 is there. Okay. Suppose if you are using the binary image, grayscale image, how many filters I need to use it to get this depth? If it is color image, how many filters I need to use this depth?
So if it is color filters, you will be using 3 filters, one for red, blue, and green. But in case if it is binary, you will be using only one, either for black or it can be for white.
No. My output shape is given. What is my output shape? 128 cross 128 cross 96. I get it. Okay. Then if it is my input is binary image, how many filters I need to use to get that size?
96 filters.
96. For grayscale, it is 96, and for color images, it will be 96 into
32, I think.
3.
By
Something like
3,
that.
divided by 3.
Yeah. Now you understand. So if I get the depth this much means I need to use that many filters. So for example, it is already color filter. I'm getting this depth means is color filter means color is a color image means already 3 channels is there. Then if I use the 32 filters, then only I will get the 96. For example, it is a binary and a grayscale. It is a single one channel. So I'm getting the size of 96 means how many filters I need to use it? 96 filters. Okay. So each filter will be generate the one matrix kind of thing. So that is the depth will give. Now you can ask the say one question or one doubt kind of thing. Sir, if I using the 96 filters, maybe I will get the same output kind of thing. I'm right. It has not happened because 96 filters contain the 96 filters have the different values. So each filter contain the different filter values is there. It will give the different information. It not give the duplicated information. It give the different information. Okay. So now it is clear what is the depth.
Yes, sir.
Yes, sir.
So these parameters you need to set at the time of convolution operation only. So along with the convolution operation, one more parameter you need to set, that is called the activation function. So maybe you already knows in neural network, but I will discuss that one also here. So now we complete the here one of the activation function is called the non-linearity activation function, that is called the rectified linear unit. So this is a famous activation function. Otherwise, you maybe you can see the neural network, some activation functions is there, that is called the sigmoid activation function and softmax activation function or tan H activation function, like this is there. But these are the not sufficient. With this activation functions, we can get the one of the issue is called the gradient vanishing problem will come. So the gradients will be vanished, means it will be slope goes to the 0. So it will not give the better accuracy. So that will be avoided with the this activation function, that is called the ReLU activation function, rectified linear unit. So it will give the non-linearity in the your data. Non-linearity in the data means, so what is the functionality of this activation function is output is the max of 0 comma input. Okay, suppose my input value is 5. Then what is the output value? What is the output value?
5.
5. Because max of 0 comma 5 will get. For example, my input value is -2. So max of 0 comma -2. What is the output value?
0.
0. So what you are understanding here? Any less than 0. Less than 0 means what? Negative values. Any negative values is there, the negative values will be converted into the zeros. Otherwise, any positive input is there, that will be taken as your output. Am I right? So what is the use of activation function? See, in the neural network, what you are doing, each input multiply with the corresponding weight. Am I right? And add the bias. Then after that only you are applying the activation function. So when you are doing this one, maybe you are getting the 205 value. Then after that you are applying the activation function and the 205 value. So what activation function? For example, sigmoid activation function you are applying. So what is the sigmoid activation function formula? 1 by 1 plus
1 by 1 e to the power of minus
x.
weight
minus x.
input.
So this will be substituted here. Then this will be produce the value ranges from the 0 to 1. Am I right? So after applying the your activation function on this value, you get the value ranges from the 0 to 1 only. Means between the 0 to 1 only, it will give the generate the output. Okay. So that is happening in the activation functions. But because of this activation functions used in each and every layer, okay, I don't know how many people knows multi-layer perceptron. At the time of the back propagation, you are updating the weights. It will not update the starting weights. It apply the chaining rule kind of thing. Okay. So every time you are applying the chaining rule, you are updating the your weights. Means what you are doing, you are taking the partial derivative of the this equation. So your activation functions everywhere is there. You are applying the partial derivative on this activation function. So when applying the partial derivative on 0 to 1, what will happen? It will be get the value ranges from the 0 to 0.25 only. Okay. Maybe here 0.24. Maybe here again positive applying 0.15. Again you are applying here 0.32. Not 32, 0.02. Again applying here 0.0001. So like this you are getting the this values chain rule. Then you can multiply these values. How much value you are getting? Like these values. This chain rule where you will apply updating the weight. The new weight equal to old weight minus learning rate parameter changing the weight. The changing the weight is partial derivative of this chain rule only. Now what is the change in the weight value? This one, this small one, 0.0000000025. And here learning rate parameter is there, that is the value is normally 0.05 or 0.5 will take. Again this multiply with the 0.05, what is the value you can get? So this is almost what? neglected value. So if it's in, this is neglected value, what is the new weight? Old weight. There is no change in the weight. What will happen? If no change in the weight, there is no change in the output. Okay. Why you are updating the weights? You need to get the tune the your parameters, means you are updating the weight, means it needs to give the better results, better output kind of, because initially initially chosen the weights are not related to your data, randomly chosen. Now you are updating the weights, means your weights are again close to the you are related to your data, but your weights are not updated. Weights are not updated means there is no change in the weight, means it's not learned to the your data related one. So output will not give the better results. So that's the reason this there is no change in the weights, means this is the called the vanishing gradient problem. So this will be avoided with the this ReLU activation function, because what is the input value is there, that input value only it is taking, so it will not change the smaller value kind of thing. Okay, that is one case. Another case is, for example, you take the any image or any kind of thing, any one contain the negative pixel values is available in the real time data. Any negative values is there?
Maybe sometimes it will be taken.
You take any image pixels, any negative values is there? There is no negative values, all are positive. But here maybe chances is there, when you are applying the convolution operations, maybe negative values will be generated as the output. Why? What is the reason?
Depends upon the filter value.
Filter values. Maybe filter values negative is there, then you can apply on that one, you can get the negative values. Then again, what you are doing, that output give to the next layer. Means your data, original data or real time, there is no negative values kind of thing. Then you are giving the next coming layers. That is a false kind of thing, information you're passing to the next layers. Then what you will get the output? You not get perfect output. So that's the reason this ReLU activation functions are very popular. So the negative values will be converted into the positive values. See here, for example, your input matrix is like this is there. Okay, then after applying the ReLU activation function, where is the negative values is there? These negative values are converted into the zeros, remaining values taken as it is. So that's the reason it will be more popular. One is avoiding the gradient vanishing problem with this ReLU activation function. Another one is that the negative values will be removed. So for example, in the virtual image, here the dark kind of information is giving. Actually, there is no negative information. The white negative came because of negative values. Then after applying the ReLU activation function, the dark will be removed. Okay. So this is also you need to specify at the time of convolution operation. So it is clear? Any doubt?
Yes, sir.
So here I am taking the some possibilities kind of thing. So now convolution operation doing stride equal 1, padding equal to 0. Padding 0 means what? No padding. We are not added padding. So if you not added padding, then what will happen? Output shape is not same as the input shape. So what is the input shape here? 5 cross 5. The blue color is the input and filter is the brown color kind of thing. So what is the filter size? And stride variable equal 1. Then what is the output shape? Input size minus filter size by stride variable plus bias 1. So 5 minus 3, 2. 2 by 1, 2. 2 plus 1, 3. 3 cross 3 is the output shape. So this is the 3 cross 3. Okay. Now here second possibility, stride equal 1, pad equal 1 you are adding. So the blue color is the input size. So input is 5 cross 5. After adding the input size, what will happen is your pad equal to 1. So one time padding equal to added, then it's converted into 7 cross 7. Okay. Then filter size is same 3 cross 3, the brown color. Then what is the output shape? 7 minus the filter size 3 by stride equal to 1 plus bias equal to 1. 7 minus 3, 4. 4 plus 1, 5 cross 5. So you're getting the 5 cross 5. Originally it is 5 cross 5. Then output size same as the input size you are getting because you added the padding equal to 1. Next, another combination. Convolution operation doing stride equal to padding equal 0 means I am not adding any 0 padding kind of thing. So what is the input size? That is 5 cross 5 means blue color, and filter size is 3 cross 3. Okay. So here you can see input size minus filter size by stride equal to plus bias equal to 1. So 5 minus 3, what? 2. Okay. 2 by 2, 1. 1 plus 1, 2 cross 2. So output size is 2 cross 2. Now another possibility, here stride equal to pad equal to 1. So what is the input size? Original input size is 5 cross 5. Then after adding the padding equal to 1, 7 cross 7. 7 cross 7. Okay. And striding equal to 2, padding equal to 1. Then what is the output size? Input size 7 minus filter size 3 and stride equal to plus bias 1. So what is the value? 7 minus 3, 4. 4 by 2 means 2. 2 plus 1 is 3 cross 3. So 3 cross 3 you are getting. But here you are using padding. Output size is not same as the input size. I'm right? Input size is 5 cross 5, but 3 cross 3 you are getting. The reason is because your stride is not equal to 1. Stride is increased more. Then in that case, padding 1 is not work. Either you can use the padding 2 or padding 3, like that you can use it to get the output size is same as the input size. So here the matrix is small one. Then based on that you are seeing and you are telling either I will go for padding equal 1 or 2 or kind of thing. But normally image size is bigger size 224, 512 like that is there. Okay. So in that case, in the coding, what we'll do, just you can use the one command that is called the padding equal to save. So using this command, then automatically how many zeros I need to add to the your input matrix to get the output size is same as the input size. So that many zeros will be automatically it will be add. Okay. So this you can have use the this predefined function kind of thing, padding equal to save. So that is the convolution layer. So after the convolution layer, what is there? Pooling layer. Pooling layer means it is the subsampling or downsampling the your input. Your input means what is the convolution output is input to the pooling layer. So it will do the downsampling or subsampling means for what you are getting the convolution operation output, that will be divided into the half of the size. Okay. So that will do the downsampling. Okay. It will be reduced to half of size. So in this three different type of the pooling operations is there. One is the max pooling, min pooling, average pooling. So this is how your input sizes. Like here you can see 4 cross 4 is there. Your input means after the convolution operation, what you are getting the output, that is called the feature map. Okay. So here 2 cross 2 filter and stride equal 2 is taking to get the output sizes off of the input size. Okay. So it is varies depending on the your stride variable or something. Okay. So now 2 cross 2 filter means it is not for convolution operation, just for selecting the your input image size. So 2 cross 2 selected. So in this, I am applying the max pooling operation. So max pooling operation, what we'll do, out of these values, which is the maximum value is there, that you can select it as the output. So which is the maximum value? 6. 6 is the your output. Next, what is the stride? Stride equal to. So stride equal to means you can skip the these two columns. Next again you can select the 2 cross 2. Okay. Then in this also, what is the maximum value? 8. 8 is the output. Next again skip the 2 rows, again come to the here because stride equal to is chosen. So here which is the maximum value? 3. 3 is the output. Again here which is the maximum value? 4. 4 is the output. So it is applicable to the stride or you can zero padding or whatever it may be is applicable to entire image, not for one time. Entire image it is applicable. So like this you are moving left, right and top to bottom, you are getting the pooling layer output. So what is the input size? 4 cross 4. What is the output size? 2 cross 2 means 4 by 2 is the 2. So half of the size you are getting. Okay. Now suppose if I apply the min pooling, what is the output values? Any answer?
1, 2, 1, 0.
So what is the minimum value here? 1. Here minimum value 2. 2. Here minimum value 1. Here minimum value 0. This is the min pooling operation. Average means in that you take the average of the values. Take the average of these values and round to upper value. Take that as your output like this. Okay. So this is the pooling layer. It will do the subsampling, means downsampling your input data. See, this is the size of the your feature map. Means after convolution operation, you are getting this one. So now you are applying the pooling layer. So the downsampling will be applicable to the only image size, not for the depth. Okay. Now what is the image size here? 224 cross 224. Now you are doing the downsampling means what? It will do the half of the reduce to half of the size. 224 by 2, 224 by 2. 1112, 1112. So 1112 cross 1112 cross 64. I said depth will not change. In the pooling layer only it will downsampling the input size only, not depth. The depth size you want to increase or you want to decrease, that you can do in the convolution layer only. Okay. So it is clear pooling layer. It is clear or not?
Yes, sir. Yes, sir. Yes, sir.
So finally one is the fully connected layer. Fully connected layer is nothing but the your neural network, multi-layer perceptron. So multi-layer perceptron, what is there? Input layer is there, hidden layers is there. That is depending on you, one hidden layer or two hidden layers you need to take. Finally output layer is there. So I said input layer means your feature vector. So when you're doing the convolution operation, pooling layer, convolution operation, pooling layer, what will happen? You will get the one kind of matrix kind of the output get. This matrix you can convert into a vector form. So that is one layer is there, that is called the flattern layer. So flattern layer, this convert into the vector. This vector is your input, then give it to the hidden layer. So how many hidden nodes you need to choose it, it's up to you. For example, my input is this is 100 is there. You want to reduce the dimensionality, you can take 50, or you don't want to reduce the dimensionality, you can take the 100 or take more also. Then finally output layer is there. So output layer is how many classes so this is also hidden layer. So output layer, how many nodes, how many class classification you are doing? 2 classes, cat and dog means 2 nodes you need to choose it. Okay. So this is the fully connected layer, just our neural network only. These are the layers. So here I'm completely showing the some architecture of the convolution neural network. So this is applied on the one data set that is called the MNIST data set. So MNIST data set is the binary image data set. So it contains the digits 0 like images, 0 images, 1 images, 2 images, like total 9 digits is there. Okay, 9 digits means total 10 classes. Okay, 10 class classification. So each input image size is 28 cross 28. Okay, so image size is 28 cross 28. Now here I am applying the convolution operation. Okay, so what is my filter size? 5 cross 5, and ReLU activation function I am using. Stride equal to 1. Okay, after the first convolution operation, what is my output shape or output size? How much I am getting? 28 cross 28. What is the input size? So I am getting the output size is same as the input size. Then what is the meaning of that here? Padding is added or not? So output size is same as input size you are getting means padding is added. And what is the depth? How many channels I am using? Depth equal to 32 using. Okay, first convolution is completed. Next, after that, pooling layer. Pooling layer means downsample. Downsample means for given a input, it will downsample to half of size. So for this pooling layer input is convolution output. So 28 by 2, 28 by 2. So 14 cross 14. Okay. So depth will not change. I said in the depth will not change in the pooling layer. Only if you want increase or decrease, that we can do in the convolution operation. then pooling completed. Next again the convolution layer, second time you are applying. Okay, same here also, zero padding added, then output size is same as a input size you are getting. Okay, and depth I increase, so number of channels now is go to the 64, previously 32 is there, now 64. Next after that again I am doing the down sampling, so pooling layer applying. So this is 14 by 2, 14 by 2 means 7 cross 7, 14 by 2 means 7 cross 7. So depth remaining same, depth will not change in the pooling layer. Then after that I have the fully connected layer is there. So fully connected layer, so every time you are doing convolution operation, pooling layer operation, convolution, pooling, like you are doing, what is the shape of the output? It look like a matrix. So what is here the shape? 7 cross 7 cross depth 64. But fully connected layer, what is take the input? It will take an input as a vector. So this will be converted into the vector. This flatten command they use. The flatten command convert the 7 cross 7 cross 64 to the vector. The vector size is 3164. So 3164 is the vector. So how many nodes is there in the input layer is 3164. Next, this is the hidden layer. So how many nodes I need to choose in the hidden layer? I said already it's up to you. You want to reduce the dimensionality of your input. Input is 3164. Then they use the how many hidden nodes? 1000 hidden nodes only they use. Okay, reduce the dimensionality. Next, this is the output layer node. So if you want more number of hidden layers, you can use the hidden layer 1, hidden layer 2, hidden layer 3 also you can use it. But they reduce to only one hidden layer they use, and next finally output layer is there. Okay, so how many nodes I need to choose in the output layer nodes? 10 nodes I chosen. Why 10 nodes? Because it is the 10 class classification problem. So that's a 10 nodes. So each one softmax activation function using, each one produces some kind of the score. The value ranges from the 0 to 1 only. For example, it is the first one reduced to 0.6, second one reduced 0.8, and remaining below second node onwards all are less than the 0.8. Okay, then which one will decide? The second node will be decided. Second node will miss 0, 1. So for example, if you are giving the test sample to this model, then what will happen? Like this scores will be generated. Once score is generated, then what will happen? Which is highest score is there? The second one is highest score is there. Second one belongs to which node? First digit 1. So that sample belongs to which digit? 1, that will be decided. So it is 1 is the label. There originally what is the label is there? 1 is there. Then both are matching. Then you can say your accuracy is 100% for this test sample. Okay. So it is clear how it is doing classification.
It's fine, sir.
So most of the main thing is here we are not extracting any features. The features are extracting. See, this is the your model. Model means you are the previous convolution neural network layer. So before that they are the extra layers. These are the extra layers I added. What I said, extra layers, that are convolutional pooling layers. So in this only it will extracting the features. Suppose I said already deep learning give the better feature representation. Only you want to extract, only you require the features only. I don't want to give to this neural network layer. Then what you need to do? You can collect the features before feed into the fully connected layer. So where this flatten layer you can collect the features. But when you need to collect the features, not starting, not one time. So this go forward pass, and after that you are getting the error. You need to minimize the error. Then you can apply the back propagation algorithm. Comes to here, again go forward, again come backward, again go forward, backward. Like that, many number of iterations you are doing. After so many iterations, then only that time you can collect your features. That features are learnable features. Okay, so like that you can collect the features. Then you can which algorithm you want, which classifier you want. For example, I want to use the support vector machine classifier, not neural network. Then you can give to this features to this classifier. It do the classification. Okay, so like that people they did that modification also, and they observed not only this flatten layer features, every layer output also it is giving the some kind of information extracting. So they will collected this place also, this place also, this place also, but it will be occupy the more memory, maybe 60 GB, 70 GB, depending on your data also. Okay. So that features also collected, and they will apply some kind of mathematical operations on that one, or reduce the dimensionality, then added to this feature values with your flatten layer features, combined and do the classification also. Like that they did the modifications. Okay. So here, this hidden layer and output layer, they use the one term is called the dense layers. Density layers. Okay, they use the term is called the density layers here. So this is your convolution neural network kind of model. So just I show the one application where we applied on the data. So my screen is visible.
Yes, sir.
Yes, sir.
Yes, sir. Yes,
So
sir.
we are taking apply this convolution classification kind of mechanism on this X-ray data images. So that is different body organs related data set. So on that you can, based on the body organs, you can classify your given the X-ray image data. Okay. So one of the model is called the AICTE model. I said in the, because of due to time we are not discussing the different models kind of thing. So one of the model is called the AICTE model, is the initial model. I shown initially in the before after feature engineering 2012 onwards, deep learning models, convolution neural network came. So that 2012 model is this one only. This is called the AICTE model. Okay. So in this case, the input image size is 224 cross 224 is there. Okay. So what is the filter size? Filter size is 11 cross 11 filter they use, and stride equal to 4 they use. But later models, they reduce the filter size and reduce the stride variable, because small filters will give the better results than the bigger filters. Bigger filters will be complete the competition will be quickly, but it will not extract the more information. So they concluded small filters only better than bigger filter size. So in this, what happened? 5 convolution operations they used. Okay, 5 convolution means convolution pooling, convolution pooling, convolution pooling, like that 5 times they use. After that, 3 fully connected layers used. 3 fully connected layer means 2 hidden layers, 1 output layer. Okay. So this model, they apply on the ImageNet data set. So ImageNet data set, how many classes is there? 1000 classes. Okay. So until hidden layer, this flatten layer, my image size is, I think, 4096 or something is there. Okay. So that will be each hidden layer size is 4096, 2048, 2048, 4096 kind of is there. So this is hidden layer 1, hidden layer 2, and this output layer. So output layer, how many nodes is there? 1000 nodes is there, because this worked on ImageNet database. So 1000 class classification, 1000 nodes is there. But I use this as my backbone model. So where I need to change it, I need to change in the output layer, because my classification task is 14 classes classification problem. So here, instead of using the 1000 nodes, I need to use the only 14 nodes. Okay, like that I need to modify. So then I applied on this medical image data. So I said every layer also generate some kind of information in this each and every layer. So for example, you can see here different each layer different kind of information it is extracting. So that will be, I am showing with the heat map kind of representation. But if we are going for the original ImageNet model, so what they claim, initial layers means starting of the layers, after the so many iterations completed, they projected the data into image format. So they observed, what is observed here, some edge related kind of information is extracting in the initial layers. Then if you go upper layers, then what type of the information is extracting? Shape related shape related information is extracted. If you go upper layers again, some kind of complete information. Complete information means, for example, face detection kind of application is there. So the face related database is there. So they trained on this kind of network. Initially edge related, only edges kind of information extracted. Next you are going for the shape, means what type of shape, like eyes related and nose related and mouth related kind of shapes are extracted. If you go a little bit higher layers, what will happen? The person's shape, entire head part, that kind of information is extracted. So most of the useful information is extracted last layers only. That's I said the flattern layers is the more unique or more learned features will be available. But every layer also some kind of information will be extracting. So like that, in my what are the input? For example, it is input image. So each layer. So here C1 is the first layer, second layer kind of thing. Every layer some different type of the information is extracted, that's shown in terms of the heat map. So here what is the information is there, here not there. Here some information, here some information is extracting. So like that different information is extracted. So total 12 classes is there, not 14, 12 classes. So I compare the this CNN results with the kind of deep learning results with the traditional machine learning algorithms. So traditional machine learning algorithm, you need to extract your own features or existing features. So one way is I extracted the initially wavelets concepts is there. Wavelets are most widely used for the medical data. So wavelets features extracted and support vector machine classifier used. So that gave the performance of accuracy of 85%. And texture features, just I discussed texture features like GLCM features and with support vector machine classifier. So that is given the 67% of the accuracy. And local features like histogram of gradient features with the support vector machine classifier. So that given the 93.6% accuracy. And with the deep learning models, that is giving the 97.6% accuracy. So compared to all these traditional methods, the deep learning is giving the better accuracy results. Okay, so this is one of the experiments for classification using the deep learning models. Okay, so you have any queries, any doubts is there, you can ask. Any doubts?
So what benefits does this have as compared to PCA in dimensionality reduction?
The PCA, what it will do, PCA only, it will not extract the features. It will be do the feature reduction kind of thing, in terms of it will be avoiding the where the redundant features is there, where is the unwanted features is there. But here it is extracting the properties. After that, you can apply the PCA on this one also, because you feel if you have the dimensionality of the feature is more. That is not extracting features. So after extracting the features, it will be reducing the dimensionality in terms of where the redundant information or unwanted information is there, that is removing with help of the PCA. But here this is extracting the properties and do the classification.
You mean to say it is more focusing on feature engineering?
So automatically learning features are not simple features. The features are tuning. See, normally, if you know a little bit deep on neural network, so initial model is what is the McLeod-Spitz model is there. McLeod-Spitz model, what will happen is only work for the Boolean functions. There is no learning mechanism kind of thing. Okay. So why we are saying not learning mechanism? Because there is no weights concept in that case. Just to take the input and sum all the input values, that is your output. Compare with the threshold. Next, what is came? Perceptron model came. Simple perceptron. Simple perceptron, what will happen? That is work for the Boolean functions and it will work for the real values. But what will happen? They will test it with the Boolean values, it will work. But if you're going for the they introduce the concept is called the weights concepts. So each connection contain the weights. So weights, what will happen? Each input will multiply with the corresponding weights and add the bias. then apply the activation function or threshold kind of thing that will show. But still up to that part, they're not shown the weights are learning or not. Okay, weights are not learned. When the weights learn, they use the perceptor learning algorithm. In the perceptor learning algorithm, only weights will be learned. Weights will be learned means what? Weights are updating.
யாருக்குமே நல்லது யோசிச்சு பேசக்கூடாது, எதுவும் செய்யக்கூடாதுடா. எல்லாருமே என்னை தப்பாதான் எடுத்துக்கிறாங்க. எல்லாருமே தப்பாதான் எடுத்துக்கிறாங்க.
So weights are updating means weights are tuning is going on. Weights once the weights are tuning is going on means weights are learning is happened. So like this here, features also learning. Learned features are more efficient than normal features. Okay.
Okay, sir. Thank you.
Yeah. Any doubts?
Sir, what are the base papers to understand more, sir?
So nowadays, lot of material is available related to this deep learning, because these are the starting kind of thing. After that, I said transform. Nowadays, transformers using like your chat GPT kind of things are LLMs. LLMs internally they use the transformers only. Okay, so that is initially transformers also developed for the sequence model data kind of thing, but later they use for the images also. So that is there. Many YouTube videos also available, and you can search in the Google. You can get the more information also. A lot of with very good animation kind of slides or any animation kind of videos also available. Lot of source is there nowadays. Or if you want to follow one structure kind of thing, in IIT Madras, some courses is there, deep learning courses, NPTEL courses is there. You can follow that one also. Is good.
Sir?
Yeah.
Sir, what is the difference between feature extraction and feature engineering, sir? Feature extraction method also comes under feature engineering, sir?
See, normally feature engineering is nothing but you are extracting the properties from the data. Okay.
Yes.
Some places they will say feature extraction is nothing but the dimension reduction method. Basically, dimension reduction method, two types is there: feature selection, feature extraction.
Yes, sir. Yes.
Okay. Feature selection means like just for given a samples, you can select the subset samples and you can reduce the which samples are good you identify. So that sub samples only you can select it, because in that case subset means you are selected few samples from the original samples. Okay. So which is giving the better results, that samples we can select it. So in that case, the selected samples is not sufficient to represent the whole data again. Reverse is not possible, because that is subpart. Now come to the feature extraction kind of dimension reduction method. So they use the concept is called the transformation or projection mechanism they use. Okay. So that n number of samples transform or project into the small set of the samples. With the small set of the samples, again you can project it back to the original samples. So that comes under the PCA, LDA. These are using the transformation projection concept. So with the help of this mechanism, again you can reconstruct the original space also. Okay. So that is the difference. Feature engineering means you are extracting the properties from the data. Feature extraction is nothing but the dimension reduction only. But normally people use the word is feature extraction means extracting the properties from the data. They they use that term also.
Okay, sir. If the data set size is very big, then we are using, sir, feature extraction or feature engineering method, sir.
See, your data size is big means sample size is big, or extracted property size is big.
Yes.
No, which one is big? Number of samples are more, or extracted properties are more?
So properties.
See, properties more, but we are not going simply dimension reduction kind of thing. Why we are going dimension reduction means maybe your data contain the redundant information or maybe irrelevant information. Simple, I will say one example. For example, you are known two friends is there. Okay.
Yes.
They're going to somewhere, some shopping or some movie. So the distance from the you and your known friends are some 300 meters is there. It's a straight line, straight street kind of thing, little bit visible mode only. Then I am asking the question, can you recognize who is the two persons? You recognize or not?
Sir, recognize, sir.
How you are recognizing their face is not visible?
Sir, we are not visible. If the face is visible, na, we should recognize, sir. Otherwise, we won't recognize that, sir.
No, it is, you can recognize. Just think in your home, your brother or sister or someone is there. They're going to somewhere, some distance is there. You suddenly came out of the home. You are seeing with some distance. Can you recognize or not?
Recognize, sir.
How you are recognizing? Face is not visible. How you are recognizing?
Trained that face, sir.
Huh?
We are already trained that face. That's
No,
only.
face is not visible. Face is the opposite direction is there. You are seeing from the back.
No, based on features, sir.
What features?
Based on the past activities.
Based on the physical properties like height, personality, gesture, walking style, dressing style, hairstyle.
Yes, sir.
Maybe this kind of properties. Am I right?
Yes, sir.
Suppose first you extracted hair color. Based on the hair color, can you recognize? The 2%,
No, sir.
2% case, because 2% hair is the same age person. Your childhood and what's your friends, same street, same village, and same classmates, and apparently same colleagues also. So hair color is not possible. Then you expected next height. One person is height, one person is short is there. Then okay, height, personality, gesture, walking style, like that you are extracting. But one statement is there. The statement is you have the more number of attributes, more number of properties, or more number of information is there, then it will give the more discrimination information. Is true or false? You have the more number of attributes, more number of properties, or more information is there, it will give the more discrimination information. Discrimination means classification. So it is true or false?
True, sir. Sir,
True.
when the no, sir, less number of features, na, we got correct identifications.
Why? If more is there, more information is there, it's not possible.
Sir, I think so, sir, but I can't.
If you say any answer, also I will say no by default. So that is
We can avoid remove irrelevant features.
Yeah.
Actually,
So
if
that
we
will
have more features, we will get confused.
Yeah, I will same example I will discuss. So the 2% case, you are extracting the height, personality, gesture, walking style, like that you are extracting. After that, you are extracting the address related, like street number, village name, district name, mandal name, state name, country name, like that you are extracted. Then after that, what is the statement? You have the more attributes, more properties, or more information is there, it will give the more information. It means more discrimination power kind of thing. Then still you are extracting the properties. Always our number of samples are fixed, but you are extracting the number of properties. Like after the extracting the street, district, mandal, or country, or world, everything is completed. Still you are extracting the properties. What properties you are extracting? USB port, keyboard, mouse, like that you are extracting. Okay. Now number of properties are extracting more. So up to some part is okay. Up to some part means height, personality, gesture, walking style is okay. Then after that, even street number also okay. But you already know same street, you extracted village name, district name. Already same village you know. Again you extracted the district. Again extract the mandal. Again extracted the state. So what is this is the information? Redundant information. Already know same street, but you are extracting this is redundant. And still some more information extracted. What type of the information? USB port, keyboard, mouse. This is the relevant to the human or relevant to the another application? It's not related to the human. Humans, we not have the USB port, keyboard, mouse kind of information. That is related to computer, means related to another data set. But you are extracting the more number of properties. So maybe when you are extracting the more information means maybe it's contain the redundant information or irrelevant information. So due to this, maybe you will not get the good results. So to avoid it, or to remove this kind of information, we need to go for the dimensionality reduction. Okay.
Okay, sir. Okay. Thank you so much, sir.
Okay.
Thank you, sir.
Yeah. So any other queries?
Sir, where can sir, sir, I'm doing my PhD in medical imaging only, but where to get the
data set, sir. Like even if we tell, they are telling me to go for the real-time data set. So in hospitals, they won't be available to get such kind of data sets, no?
No, what application? Based on the application, we can say.
Yes, sir. Mine is related to personalized imaging using GANs.
No, that is your solution. I'm asking what medical data you want to do.
Like breast cancers kind of
That is
data.
that is available in Kaggle.
Kaggle.
Okay. In Kaggle,
Okay,
many
sir.
medical data sets are available.
Okay. Okay, sir. Thank you.
Yeah. So any other queries?
So, can you have some comments on the data validation?
Data validation, depending on the your which one?
Hello, am I audible, sir?
Yes, certainly.
Yes. Okay, my question is how to go for data validation, sir? Because most of the cases we are referring to websites, for example, like Google, and we are claiming that okay, already the available data sets over there are accurate or verified data sets. Okay.
Yes.
And even if I refer those data sets, there are some lacunas in it. Okay. So my question is within that data sets, how we will go ahead with what the validations, because this one is a very good point about the data perspective. If my data is not good enough or it is a fabricated or manipulated, my whole the design, whatever I'm looking for, that one is also affected.
See, one thing, you are already existing applications you are doing, lot of benchmark data sets are available. Okay.
Yes.
So in that case, no issue. If you can use exactly what they mention, your splits kind of thing, everything, you can use it. You can validate your data with available metrics. Suppose you have come up with a new application kind of thing, maybe the data you are collecting your own kind of thing. Okay. In that case, you need to follow the some kind of standardization. Standardization means, for example, a lot of variation is you need to create your own data. For example, you can see that some challenging issues is released every year. So the challenges are how they will do. Lot of variation is there, training and testing sample. Okay. What type of variation? Simple example I will give. For example, one tree is there. On the top of the tree, one small bird is there. Okay. So your data collection related to the collecting the images of that bird. Okay. So first one day you went, you fix the camera and capture the some images. And evening also you capture the some images. And day two event, you are fixing the camera some little bit more distance compared to the yesterday one and capture the some images. And day three also went, you can fix the camera some little bit another direction and capture the images. And fourth day also you went, but you taken the different camera and capture the same object. So all the days you capture the same object only. Object is not moving, object is in the same place. Okay. My question is, on first day you collected the some morning images and afternoon images. Any changes is there?
Yes, sir. Sunlight.
Obviously. Obviously, some
What type
changes
of the changes?
Changes we can
The
see
lighting conditions related.
Yes, yes.
I'm right. And
Yes,
what is the
intensity
difference
condition.
between the first day and second day?
Okay, the similar kind of differences, sir. Position,
First day is
environmental
your camera is near to
situations.
the tree. Second day is some distance you maintain. So what type of the
Yes, yes,
difference it is?
Okay.
Scaling kind of thing. Because when your camera near to the tree, object will be appeared as a bigger one. If you maintain the distance, some long distance, the object is appeared as a small one. Am I right?
Yes, yes.
And
Correct,
what about second day and third day?
Afternoon and morning.
No. Second day, third day, I going to different angle.
Positions, yes, sir.
The rotation will come, because rotation issue will come when you are capturing the bird first. For the first day, second day is front view you are capturing. When you are going for another direction, maybe that is the side view will come, or maybe some of the body of the bird will be covered with the leaves, so it is invisible kind of thing is there. Half of the part will be visible, so that variations is there.
Yeah.
And third day and fourth day, different camera, different resolutions, means brightness changes kind of thing is there. So suppose in the first day morning you collected 20 images, okay? The 20 image, same environment, there is no contrast, no brightness changes kind of thing. 10 images I keep it in training, 10 images I keep it in testing. Then how the accuracy will get?
Yeah,
Yes,
correct.
Good or bad? The
100%
same time
accuracy.
capture, 100% you can get. So this challenging releasing problems, what they will do, what is your getting created first morning images, it keep it as a training. What is this variations is there, that they're taken as a testing. Then you prepare the model need to learn or detect all these variations. Like that you can build your model. So at the time of your data creation also, you can create like this variation. If you not created this variation, what will happen? You are training and testing, you are creating more same kind of thing. Only one modification, contrast variation is there. Then